Okay, welcome everybody. How great to have you all with us today and to help you to be really well prepared for your Year 12 exams. My name's Jane Sydenham-Clark and I'm Skyline's CEO. Welcome to you from across our First Nations lands. For me, I'm diving in from what always was and always will be Wurundjeri country. I acknowledge the traditional owners of our lands and pay respect to elders past and present. I recognise sovereignty was never ceded and regret that there is still no treaty. Over the next 5 days, Skyline Hatch will be delivering curriculum revision, so you're on top of the required content for your VCE exams. But importantly, our Skyline alumni and their peers who have scored great ATARs themselves will also be sharing their tips, tricks, and hacks, not only on what you need to know, but also on how to manage yourself. To give you the edge, we're looking for you to be at peak performance when you sit down to write these exams. Like the coach of an Olympic athlete, we want you to be peaking at the right moment. It's with huge gratitude that I acknowledge my colleagues who have worked so hard to make this series possible, particularly Sally Watts, Andrew Power, and Ms. Westcott, and to our incredible Skyline alumni and their peers, Adrian Ferdinand, Alice Nowicki, Theano Salter, Rakeo Sadecki, Liam Jones, Susan McAloff, and the whole Hatch team. Thank you all so very much. I hope you're feeling really satisfied with your achievements to date and that this only grows in the days ahead. This series is possible thanks to extraordinary generosity from our wonderful partners at UBS, who have believed in us and backed us for over 3 years on our journey of growth and discovery at Skyline. The kindness of the UBS team has enabled high potential VCE students in challenging circumstances to join Skyline's 2-year program. Their support has ensured that students without laptops are gifted computers so they can undertake their VCE, and their kindness has extended in so many ways to make such a huge impact. For the 2nd year running, UBS and their foundation have supported this exam revision series, helping us to grow from extremely humble beginnings into where we are today. Thank you so much, Katrina, Ben, Tom, and all our brilliant UBS volunteers who are supporting us this week. And please, welcome to address us, Managing Director, Inspirational Leader, and dear Skyline friend, Kelvin Barry.
Thanks, Jane, and good morning, everyone. I'm Kelvin Barry, one of the Managing Directors at UBS in Australia, and on behalf of all of the team at UBS, we're delighted to partner with Skyline to help deliver this year's VCE exam revision series. As Jane says, we're a proud supporter of Skyline in many ways, and we're delighted also that this year again, we have quite a number of our junior staff joining the exam revision series. Thanks to all of the Skyline team and most importantly, all of the tutors for all of your efforts in putting together what I'm sure will be a wonderful series and something that gives all of the participants a great competitive advantage. But most importantly, a few comments to you, the students. Firstly, well done on putting in the effort to participate in your studies and the effort to participate in this exam revision series. I'm sure you'll get great returns from the time you're investing in this program. Secondly, we'd encourage you to make the most of the series. It's a great opportunity for each of you, whether an opportunity to catch up on some of the things that you've missed or are unsure about, an opportunity to consolidate things and reconfirm your learning, or an opportunity to get a step ahead of others. I'll make a few brief comments about the year because it's been a very difficult year. It's presented challenges for many people, and I'm sure most of you. What I would say, though, is don't underestimate what you're able to do. Don't underestimate your resilience and your capacity, and make the most of the support that is available to you, whether it's through Skyline and this program, through your schools or teachers, other students, family, or friends. Be resourceful in thinking about where you can harness additional support to help you in your journey. I'm sure over the coming days, you'll learn not only lots of great content from the Skyline Hatch tutors, but also, as Jane says, some tips and trips around how to go about exams. I still remember my exam preparation, and interestingly, some of the things you learn on this journey stay with you as you go into university, work, and other careers. I remember there are 3 simple things that I was taught, which still I use today. The first is, if we're feeling a bit anxious, think of this as actually an opportunity to demonstrate what you do know, as opposed to a test to find what you don't. Secondly, make sure that you read, think, then write in that order. It's amazing how often that still is very powerful today in terms of following those 3 simple steps. And finally, plan your time. Make sure you give yourself an opportunity to cover all of the questions and to demonstrate what you're able to know. Again, we're delighted to be involved. Thank you, Jane, and her colleagues. Most importantly to the students, well done for joining. Make the most of this week. And on behalf of all of the team at UBS, we send you our very best wishes and good luck for the exams ahead. Back to you, Jane.
Thanks so much, Kelvin. And now to introduce the rock star for today, the wonderful Adrian Ferdinand, who will be taking you through everything you need to know with respect to further math, and supported by the incredible Alice Nowicki, who will be his right-hand person, sharing the insights that are going to give you that competitive edge that Kelvin is talking about. Over to you, Adrian and Alice.
Hi everyone, so I'm Alice, as Jane just said, and we have Adrian here. So we're just going to start. Firstly, I'd like to acknowledge the traditional custodians of the land we are gathered on today. I pay my respects to the elders past and present, for they hold the memories, the traditions, the culture, the hopes of Aboriginal and Torres Strait Islander peoples across the nation. So quickly, we're just going to go through some Zoom etiquette. So firstly, we will be using the Zoom chat for any immediate questions. So if there is a technical difficulty or something that immediately needs to be adhered to, please comment in the chat. But for all other queries, we will be using Mentimeter. So if you guys could please go onto menti.com and use the code written here, or you could scan this QR code and you can use the Q&A function on Mentimeter to ask any questions you might have, and we'll also be doing a few quizzes through Mentimeter. So I'll just give you a minute to do that. The Mentimeter code will stay down the bottom of all of the slides. So a little bit about Skyline Hatch. So Skyline Hatch is a program that complements your learning in the classroom, and we provide weekly tutoring and masterclasses and other programs such as Stress Hack. We are a new social enterprise with profits that are being invested back into the Skyline Education Foundation. So that means by signing up to Hatch classes, you're also supporting Skyline Education Foundation to help more young people reach their full potential. And you can find out a little bit more about Skyline Foundation on our website if you would like to learn more. So about us, I am Alice, and I graduated from Caulfield Grammar in 2018, and I'm currently studying a Bachelor of Science, majoring in physiology. But I have been tutoring further maths ever since I finished school, and I love tutoring further because it is a math subject that teaches you a little bit more than just maths you are going to be using in an exam. It helps benefit you beyond the classroom, especially the financial maths is really important for later life. So that's a little bit about me. And we also have Adrian, if you want to introduce yourself.
Hey everyone, so my name is Adrian, and it feels really surreal to be here because I graduated from Skyline Hatch and VCE just over 10 years ago. And I've been tutoring further maths ever since. So it's been 10 plus years of tutoring further maths and, seeing the curriculums change and things like that. A little bit about me, I am extremely passionate about, teaching and learning maths. And just like Alex said, I think the great thing about further maths is you learn content that's quite practical and applicable to the real world. So you'll notice some of the content that we covered today, especially in financial maths, quite relevant to what you will be using in the day-to-day life. Cool. Alice, I'm going to start sharing my screen then. All right. So in terms of today's agenda, everybody, we will be covering the core component of further. So essentially the data analysis component, which makes up majority of your exam, and also the financial maths component. In terms of the other modules, we will talk about some of the other offerings that we have for the other modules at the end of this session. So we've essentially what we've done here is we've gone and recognized the different areas or the type of questions that are used in exams, and we've pretty much compartmentalized exam questions based on the concept that they're trying to assess. And you'll find that handy. So one way to make sure you can perfect your capabilities in further maths is make sure you can perfect each component that sits within each of these concepts that they assess you on. Just a little disclaimer. So obviously, given the time constraints, we won't have time to go through all the questions today. However, we've selected some good questions that we believe would capture the concepts. In terms of the solutions for the questions that we don't cover, they're all accessible on the VCA website. So all you have to do is go and search up the exam and the question, and you should be able to read up the reports to identify the answers. Cool. So here's a bit of a timetable. Long day, but a couple of breaks, and we hope you will stay engaged throughout the day. The more you engage, the more you will retain. So keep that in mind when you are listening. Follow through with the questions. Make sure you've got your calculator all charged up. You've got your sheets of paper that you're writing on, annotating on. The best way to get the most of today is to stay engaged throughout and ask any questions that you need help with. All right. So to kick us off, we're going to start with essentially trying to gauge where we're at the moment, right? If you could all please go on to menti.com for me and use the code that Alice mentioned earlier. I will have posed this question for you guys. So how confident are you feeling about the further maths exam, which I believe is just over a month away. So where are we at the moment? So you should be able to, select some values on the scale.
9408. 9408.
Let's reload this to see if that's changing anything. Does everyone have access to this? Oh, quite a few of you having technical difficulties. All right, guys, can I get you all to? All right, I can see it move. That's a good sign. All right, we've had about 131 responses. So we're around about a 3. Okay, that's all right. We've got quite a few weeks to go. And hopefully by the end of today, having covered the core and the financial maths components, we'll be able to see this confidence level go up. All right. And at the end of the session, I will run through some tips and tricks that you could potentially use to compartmentalize the exams and work through the challenge of covering so much content. All right, so let's begin. So the first thing is, and as we go through the exam questions, you'll notice there's opportunity to get some easy marks, okay? Because the content is so broad, and there are challenging questions, obviously, but there are some easy topics that you can get some easy marks on. So one of the first things that we need to recognize is with our data and stats is the types of data. So we've got the two main types of data. So we've got the categorical data and numerical data. And the easiest way to potentially try and identify this is you might want to think, does it make sense to calculate the average of this data set? Okay, that's one of the easiest way to try and identify this. When it comes to numerical data, and if you can, there's a chance that it is numerical data. And then when it comes to numerical data, you've got continuous data. So things that you normally measure, things like height, weight, time. And then for discrete data, you've got things that you would count, right? So for example, you could say 1 banana, 2 banana, 3 bananas, or number of people in a car that passes down the street. For categorical data, you've got ordinal data and nominal data. So ordinal is where there is a natural order. For things like temperature, you've got high, medium, and low. And then nominal data is where you've got, you're categorizing according to their names. So things like eye color or things like suburbs are classified as nominal data. Cool. So what we might do is I'm going to give you guys a quick minute or so to do these two questions, and I'll start going through them. So we're only going to go through the highlighted questions today, guys. I'll give you guys a quick minute to have a crack at that. Alice, I'm counting on you to keep an eye on the watch and let me know when we've got to switch over. Cool. All right, I'm going to get started. So we are asked to recognize or identify what type of variables these are. So trap type is nice and easy. You know that is going to be a categorical variable, but they've gone on to mention nominal and ordinal as well. So that would be a nominal variable. And over here, this is categorical. However, there is an order to it, right? Yep, we've got an order to it. So you would say the number of moths is an ordinal variable, and the trap type is a nominal variable. Hopefully you guys have managed to get that answer. Feel free to use the chat function if you'd like with these, but you're going to have some opportunity to answer some questions for us on Mentimeter in a moment. All right, so we're looking at recovery time in minutes. So minutes is something that we can count. Minutes is something that we can count. So that is going to be a numerical value. So I'm going to say a numerical. Fitness level below, so that's going to be a categorical, but let's see if they've gone on to further classified. Okay, so what are we saying here? Recovery, we've got numerical and categorical as ordinal, right? Because we know that above average is below average, and above average has some sense of order to it. Cool. If you do have any questions, feel free to post it in the chat. All right, moving on.
Adrian, just before we go on, there is a question in the chat that you go back to the previous slide where you just outlined the difference between categorical and discrete data. I think an attendee just wants to have a look at that again. So I'll leave it up there for a few seconds.
Thank you very much.
Thanks, Adrian.
So these should be available on your slides that were attached to eventee.com as well, guys. If you log into Eventee, you should be able to download all the slides with the content. And Andrew here has posted it on the chat for you. All right. Cool. All right, let's have a look at this one. So this question is asking us the number of discrete numerical variables in this data set. So discrete numerical. So discrete is things that we count, right? So we know easily that the gender of a person is not discrete. The number of children, yes, it is. The type of car is not discrete. Postcode, because what do you think postcode is? So in terms of the postcode, right? So let's say, for example, 3174, 3175. This is actually trying to categorize postcodes. The easiest way I explain this is the postcode 3175 has no numerical value. There's no 3175 is not better than 3174. Okay, right? So there's no numerical weighting towards it. It's actually a categorical variable. And in fact, it's actually a nominal categorical variable. So it's just the name. 3175 is the name of that postcode. Similarly, it's similar when it comes to mobile numbers as well, right? And another thing to look at postcodes is it doesn't make sense to calculate the average of the postcode, average of postcodes of all the attendees in this Zoom webinar and say on average, a person from 3174.5 attends this webinar, okay? Right, so remember how I said, think whether it makes sense to calculate the average to identify whether it's numerical or categorical. So postcode, it doesn't make sense to calculate the average that way. Things like mobile numbers, once again, is a nominal variable. So I'm going to eliminate that as well. So now we're tossing up between number of children and distance. Is distance discrete or I can see a lot of going on in the chat. Will someone raise it if it's something that I need to pay attention to? It looks fine. Yeah. All right. So things like distance, it's measured. So you've got one discrete numerical variable. Cool. So I'm going to move to question number 4 here. What I'd like you guys to do is go on menti.com and answer. Oops. Oh, got some questions coming in. And I'd like you guys to answer this question on menti.com. So I can see seven of you have engaged with the questions. So this one's relatively easy, I'd say. Oh. All right. I'll wait for this to get to 80, because don't forget with further, it's time sensitive as well. Oh, all right. So you guys have identified the correct answer. So megajoules, it is a numerical variable. And in terms of the capital city, like I said earlier, things like postcodes, capital cities, they are nominal variables. Fantastic. All right, moving back. Okay, we've got a couple of more of those. So let's do this question here. We've done this, the number of mods question. Let's look at question number 8. So recovery time after exercise in minutes and fitness level as below average, above average, and so on. So this one's easy. This one's ordinal, right? So I can get rid of this. First one's not ordinal. eliminated, bam, E, right? So a lot of the times you'll see that you can eliminate a lot of the answers without even having to check all your questions. Some of the strongest students will manage to finish the MCQ exam with about half an hour to spare, because they will use methods of elimination to identify their answers. All right. Once again, we've got, which of the two variables is a nominal variable, quite easy to identify. That's going to be the type of mammal, right? Cool. All right, so we've now moved on to the next subtopic, which is categorical data. And a very important concept that they check, and you can see there's about 1 or 2 marks allocated each time, is your ability to go from count to percentage, right? So percentage is generally count over total count. Multiplied by 100%. They're asking us how many of the 96 birds have small beaks, right? How many of the 96 birds have small beaks? Yep. So what have they done? They've given it to us in percentage. So they're saying 25% of birds have small beaks, right? Okay. And that means to convert it into the count, to identify what the count is going to be, you're going to multiply it by 96. If 100 of them have 25 small, sorry, out of 100, if 25 of them have small beaks, how much would it be if it was just 96? So that's quite easy. Divide that, that's 1/4. So that's going to be 24. Cool. Also important that you're able to go and identify or construct segmented bar charts or stacked bar charts. So with these ones, you want to first of all go and recognize what your axes are, right? So sometimes they'll give that to you in count, sometimes they'll give that to you in percentage. Please make sure you're paying attention to those axes when you're going and constructing these segmented bar charts. So in this case, we've got 25% that have small beaks, nice and easy. Can go and construct that, and the small beaks are going to be dotted. And then you've got 44% that will have medium. So you've got to go 25 plus the 44, that's going to be 69. And then you draw the line at 69. They're going to have medium beaks, and the rest, which is 31%, will have large beaks. All right, so now we're getting towards the numerical data concepts. Now, with numerical data, you've got to be confident in how to use your calculator. So in this question, they're asking us to calculate the mean and standard deviation, right? That is another concept that you want to make sure you understand quite well, because it's it's in essentially every single further exam. So we've been asked to calculate the mean and standard deviation. I'd like you guys to use your calculator and respond in the chat. Let me know what the mean and standard deviation for distance is. So that is distance is this column here. So in terms of the steps, whether you're using your TI Inspire or ClassPad, you would have to go to your list and spreadsheets, and you would have to plug in your data values going down. And you would have to calculate one variable statistics. Okay. Alice, are you able to plug that in for me? Or actually, we might just hold off and wait for a couple of you to use the chat for us. All right, brilliant. So we've got the mean, so that's actually X bar in each of these questions, right? The mean is 2.8 and the standard deviation is 1.8, right? Brilliant. All right. Alice, are you taking over now, or you want me to finish this question?
Yeah, do you want to finish this question then?
Yeah, no problem. All right. So another important sort of concept that they will test is your ability to recognize what a data set would look like in terms of a graph. So in this case, we're looking at a box plot. Now, there's probably quite a few ways that you can go and do this question. The first thing is, don't just assume because we have three outliers in the dot plot that all of these three outliers would be in your box plot, and don't just assume that it's going to be these two answers. Okay, so with all of these, you definitely want to go and calculate your lower fence and upper fence to ensure that you've mathematically recognized what an outlier is. Because it is the right-hand side of this data set that's in question, I'm going to stick to that, and I'm going to go and calculate my upper fence. So to calculate my upper fence, I need Q3 or quartile 3 plus 1.5. Whoops, what's going on here? Times the IQR. And we know that the IQR is actually 1.5 times Q3 minus Q1. Now, to try and recognize these values, if we've got 50 data sets, right, or 50 data values, your median is going to be 50 plus 1 divided by 2. This gives us the position of the median. Okay, so that's going to be 25.5, right? Or it's going to be between the 25th and 26th data values. So I'm going to start counting, and I'm going to count from the right-hand side. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. Okay, that's going to be a problem. So your median is going to be between these two pillars here. So I'm going to say that's approximately that's actually not important to me. So I need to find Q3. So Q3 is going to be the middle of the second half, right? So in the second half, we've got 25 data values, 25 plus 1 divided by 2. That's going to be my 13th data value. That's going to be Q3. So I'm going to start counting. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 50 is going to be Q3 for me. And in terms of finding Q1, again, it's the same concept. It's the middle of the first half of data. I've got 25 data values on the left. I'm going to go 25 plus 1 divided by 2. That's my 13th data value again. And it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So Q3 will end up being 30. So that's going to be 50 plus 1.5 times 50 minus 30. That is 50 plus 1.5 times 20. And 1.5 of 20 is 30. So that's 80. So 80 is my upper fence. And that just means I will only have 2 outliers. And that would eliminate this, that would eliminate this, that would eliminate this, and this, leaving A as your final answer. Okay, so hopefully that was useful. Cool. Alice, you taking over?
Adrian, I might just jump in there very quickly. Yeah. Thank you for stepping through what you've stepped through thus far. Yeah. It's all very well taught, I think, and very useful. As a banker, every day we are identifying different types of data. We're identifying whether or not, data is categorical, numerical, ordering data, finding averages, those sorts of things. They have real life and professional utility. So further mathematics is a great example of a VCE subject that has real life uses. So certainly worthwhile getting across this sort of content and listening to Adrian and Alice teach it very well.
Thanks, Ben. Ben, do you want to share what you do at UBS as well?
Absolutely. So I am an investment banking analyst in the industrials team in UBS Melbourne. What I would liken my job to is effectively a real estate agent. So I, instead of selling property, really help facilitate the sale and purchase of businesses. So that's what fills my day to day. And I find myself using my further mathematics skills frequently. So
perfect. Thanks, Ben. Over to you, Alice.
Cool. Okay, so we've touched on it a bit already, but we're just going to go through the different types of displays of our univariate data. So firstly, we have frequency tables. So frequency tables mostly display continuous data. So they would always have like the intervals so in this case, this example here, we have siblings, and there is like the number and then the frequency, which is the number of people that have that many siblings, right? Sometimes you might, instead of having like in this case, we have siblings, it's just 0, 1, 2. Sometimes what you might have is that instead it might be like 0 to 1 or something like that. It might be an interval. When you have an interval like that, when you're putting the frequency table into your calculator, you can't just put in the interval 0 to 1, right? We have to only put in one number. So what you would do in that case is you put in the middle value of that interval. So in this case, you would put in 0.5 if the interval was 0 to 1. So that is a frequency table. So another key thing to remember with the frequency table is that it is frequency, right? So these are representing the number of times each case is happening. The next type of display is a stem and leaf plot. So this summarizes, again, numerical data. And really importantly, we must have a legend on these plots. If you're asked to draw one in the exam, make sure you have a legend. So you can see down here that we have our legend in that 2 and then the line 5 is equal to 25, right? In some cases, so really important to know that because maybe it might be in another situation where that would be 2.5, right? So legend, super crucial. So we have the stem on one side and then the leaf. Obviously, this represents, this one would represent 4, then we have 14, 16, so on. Really nice way to represent numerical data, shows the spread of the data as well. Really good to visualize if it's what type of skew we have or if there's any outliers. Next, we have bar charts. So bar charts are for categorical data. And you can see that, again, it's a bit blurry, sorry for that, but we have frequency on our y-axis, and then on our x-axis, we have the different categories. So in this case, we have low, medium, high, and very high for a developmental index. Each bar represents the frequency of that particular category. And the most important thing is that the bars do not touch. You can see that there's a gap between each bar and that our widths for each bar are the same. So that is what differentiates a bar chart and a histogram, which we'll come to later. That the bar charts, there is the gap, and histograms, we don't have a gap. Segmented bar charts are quite similar to bar charts, except rather than we have like having a different bar for each category, we have just one bar, and that is segmented. So the total frequency, so if I draw an example, the total frequency would be 100%, right? Or like whatever the total frequency, and we have a bar, and then that might be segmented into 2 or 3 different parts. And we also need to make sure that we have a key for this one. So we might say that equals the different, and then we make sure we specify what each part of the bar chart represents. And each little part would represent, maybe this would be 80%, and this would be, so then you could say that this part would be 60%, this is 20%, and this is also 20%. Next, we have dot plots, which you saw in the question before from Adrian. So a dot plot is quite similar to, it displays, I guess it's quite similar to a bar chart in that it displays the number of points at each category. So in this case, each dot represents a single data point. So it might be frequent, so then you could add up the total frequency for each point. And it also shows the shape of distribution. Histograms, as I was saying before, we have that the bars must touch. So if we draw a histogram, it will look something like this, in that we have all of our bars touching. Like this, right? And in this case, rather in our bar chart, we had that it was for categorical. In histograms, it's for numerical data. So it is continuous data. It could be either discrete or continuous. So if it's discrete, our bars lie above the numerical values. So we would have our values in here. Maybe this is 15, 20, so on. But if it's continuous, we have our bars lie between the values. So that would be like, this would be 0, 10, 20. So then in that case, we're saying that this bar here is representing the number of values between 10 and 20. And finally, we have box plots, which we saw before, but we have something like this. We have our minimum value here, Q1, median value, Q3, and our maximum value. And we might have outliers, which we can represent with a cross, but we will go through that now. So when we have these different ways to display our data and our data, we might want to analyze this data so that we can make some good, we can, make assumptions and understand what our data is telling us. So we have 3 measures of center when we're analyzing. We have mode, median, and mean. Our mode is our most frequently occurring value. So that's quite self-explanatory, I think. Our median is our middle data value, and this is not affected by outliers or any skew, whereas our mean value is the average value. So you add up all of the values and divide it by the number of values that there are, and this is affected by outliers and skew. So when we're thinking about which measure of center we're going to use in our analysis, we have to be considerate of if it's symmetrical data or if there is a skew and if there's outliers. We also have different measures of spread. So we have a range, which is our maximum value minus our minimum value. So that is like showing the total value, like, yeah, total spread. We have our interquartile range, which is showing the spread of that middle 50%. So our Q3 minus our Q1. And then we also have standard deviation, which you can get the value for from your calculator. When we're analyzing our data, we calculate a 5-figure summary, which your calculator can do for you when you put all the values into the spreadsheet, and you can get the 5-figure summary. So we have our minimum, Q1, median, Q3, and maximum, which you will notice is the same values as what's in our box plot, right? As Adrian alluded to before, we have our formulas to calculate the lower fence and upper fence. This is important because we need to know how we can know if we have outliers. So outliers are on either side of the lower fence or the upper fence. So if they're lower than the lower fence, then they're an outlier, or higher than the upper fence outlier. And lastly, last bit of content before we do some questions is the measures of our, like, how it's spread. So we can have a symmetric distribution, which is the median value is in the middle, and it's like nice and spread evenly around our median. Positively skewed is that our median, we have lots of values at the start. So our median is on the left-hand end of the distribution, and then it kind of tails off by the right end. And then negatively skewed is the opposite. We have lots of values on the right-hand side of data. So our median is more towards the higher values of the distribution. And there's less values in the lower end. So let's go forth and do some questions. Let's go hop on to Mentimeter and do question 6. Give another 15 seconds to put in your answer. Oh. So A is our correct answer. I'm not sure. Oh, we've gone too far. Sorry, guys. Yeah. Hold on. Let's just go back to our question. So we had a bit of a split between A and C. So on this one, if we're wanting to, we have 53 countries, less than 2 billionaires. So we are looking at less than 2 billionaires is between 2 and 0, right? And you can see that this takes us to 45, 46, 47, 48, 49 is where we have 49 people between 0 and 2. So 49 divided by 53 times 100 will give us our percentage, which
92.
is 92.
2.45. Yeah.
D is our correct one. Let's move on. Running a bit low on time, so we're not going to get through all the questions that we've highlighted, but let's look at this question here where we are asking the shape of our distribution. So we can see that we have lots more values in the right-hand side of our data. So that means that we have a negatively skewed distribution. So our median will be somewhere on the right-hand side. Let's do question 1. So we have the total amount of energy is recorded each month for 22, and they're showing us the month of February for 22 years. So we have 22 data values. Determine the number of years in which energy during February was greater than 23 megajoules. So we have 23 here. We want greater than. So we have 1, 2, 3. 3 years would be our answer. So we write 3 years. The first quartile is at 20, and the third show that 17.1 is an outlier. So 17.1 is, we're looking at our lower fence. So we need to find what our lower fence is. Remember that the formula is Q1 minus 1.5 times IQR, which is so we get 20 minus 1.5 times 1.8. And 17.1 is lower than 17.3, so is therefore an outlier. Now we have to complete the box plot. So we know that 17.3 is our lower fence. So we've given us one outlier. We don't have any other values below 17.3. We only have the one outlier. So now our line, our minimum value will go to this value here, which is at 18.2, right? So we're going to draw a line there and connect that to our dot plot. We were told we have to work out our median. So we have 22 years. So the median will be at n plus 1 over 2. So 22 plus 1 over 2 is 23 over 2, which is at 11.5. So if we count backwards, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It will be in here, which is at 21. So we can draw our median there. And then our maximum value is at 24.4. So we can draw our other line here. And then we have our box plot, which you can see is pretty symmetrical if we were then asked to analyze that. Let's do these question 1 here. Describe the shape of the distribution. And so type in the chat what you yeah, I'm getting that it's positively skewed. Good job. And the data value 52 is below the upper fence and is not an outlier. Determine the value of the upper fence. So upper fence is going to be Q3 plus 1.5 times IQR. We can see that Q3 is at 39. Q1 is at 30, so that makes our IQR 9. 1.5 times 9 is 13.5. So our upper fence is at 52.5. I think we're going to have to move on to the next content, which is our...
Hey, Alice, we've got a couple of questions just on the box and whisker plots, and also just generally actually creating box plots by hand. A question from Bailey. He's asked, when answering questions where we have to create graphs, etc., do we get marks off for minor inaccuracies?
I think like you want it to be as accurate as you can be, but obviously I think most of the time, oh, where was this one? They give you lines, right? You can see here, like there's not, in this example, there's not really any excuse for inaccurate lines because they've given you all the points. So you probably would get a mark off if you drew your line to here because that would be the incorrect value, right? So really work on being as accurate as you can be.
And we've just got another one in from Erin. Erin's asking, well, she says that she was told not to draw vertical lines at the end of the whiskers because it's definitive. How would you approach that typically, Alice?
Yes, Adrian, what do you?
I might jump in here. I haven't seen any significant notes in the reports around that line. But if you've been told that way, you can leave it out. But I know that, a lot of the folks tend to draw the lines. You're not going to get penalized for something like that in further. Yep.
You can do it.
Good question though. Yeah.
Works for you. Let's go. Okay.
Logs. Yeah.
Base 10 scales. So sometimes we have really extreme ranges in our values. So what we have is log scale so that we can see values from really small to really large within one graph or within one table. So it's just an easy way of displaying this value. So if we're going from a log value to so basically what we have is that we have log 10 A equals B, right? What we're saying is that B is the power. So if we said 10 to the power of B is equal to A, that is the two ways of putting it. So if we're going from the log value, so B, to find A, we just go 10 to the power of the log value and you'll find the actual value, and vice versa. If we're going from the actual value, we do log 10 to A will give us B. Let's just do one Mentimeter question. Let's do
Let's do question 7, Alice. I think that one's a good one because I feel like a lot of folks have got that one
wrong. Cool.
Yeah.
7. Let's.
Perhaps if you press the back button at the top, you might be able to select the slide. Yep, that one. So this question, guys, is actually one of them questions that majority of weaker students have got wrong. So
Okay, let's.
might have to refresh.
Is that coming up?
Yep, perfect.
So we have got most people saying A. But the correct answer is E. So we're going to go through that now. So the number of countries with 1 or more billionaires per million people is. So we have on our X, we have our value, our log values. So that is not the number of countries with 1 or more billion. That is the log values. So a lot of you were just saying A, which is 1. And yes, we have one value between 1 and 2, but that is
between 10 and 100.
In 10 and 100, not yeah. So we need to think about using our log scale for that rather than just reading the graph. So the number of countries with 1 or more billionaires per million people. So what we need to convert our logs. So we're looking between, it should be in
greater than the 0.
Right? Because we want log 10, 1, which is equal to
0.
Right? Cool. Let's move on to normal distributions. Well, we meant to have a break.
Let's take a break now. When we come back, we can continue because we've got a bit more extra time with the other 2 sections anyway.
Yeah, we'll come back at 11:15.
All right, everyone, welcome back. We are going to get started with the content. So the next concept or next topic that we need to try and understand is the normal distribution and standard deviations. So here we've got the bell curve, and hopefully by now, you've done many questions relating to the bell curve. But what Alice has already gone and done for you is she's essentially broken down the percentage of data values that would fall between the mean and each of these standard deviations as well. So you can see, they say there's 68% of the data values that fall within 1 standard deviation from the mean. You've got 95% of data values falling between 2 standard deviations from the mean, and 99.7% of data values falling within 3 standard deviations from the mean, and so on. Hopefully we'll learn some of these concepts as we, solidify your understanding with some of these concepts as we go through some questions in a moment as well. So for us to be able to compare different data sets, we tend to standardize, sorry, I should say numerical data sets. We tend to standardize their scores, and we standardize them and we call them Z-scores. So this equation here of how to calculate the Z-score is also going to be important. You might notice that sometimes they will transpose this equation, or they will expect you to transpose this equation and find other data values or other unknown components within this equation as well. So this equation can be moved around. Make sure you're familiar with that, that type of question as well. So obviously with the Z-scores, if a certain data value is above the mean, so if it's on this side, you will have a positive Z-score. If it is on the left-hand side of the mean, you will have a negative Z-score, and so on. Yeah, so and like I said, they will ask you to compare certain scores from, for example, different subjects by standardizing the data set first. Cool. All right. To kick us off, I might go and do this question here. Alice, I might need you to help me out with the calculator stuff. So we're going to look at question number 5 here, guys. We've been given the mean and standard deviation for population density and area. And what have they said? They've given us a random data value as well. Determine the standard Z-score for this suburbs population, and they want us to round it up to the nearest decimal place. So to calculate the Z of the population density, so that's going to be the actual value, which is 3,082. Take away the mean of population density, which is 4370. And I've got to divide it by the standard deviation of that value of population density, which is 1,560. Alice, what have you got? You're on mute as well, by the way. Someone's asked me, do we use mu or X bar? I wouldn't stress too much about that. Mu is actually the same as the negative. As bar. Yeah.
Negative 0.3.
Negative 0.3. I'm not hearing the first number you're saying.
83.
Thank you. They've asked us to interpret the Z-score of this suburbs population density with reference to the mean population density. So you would say the population density, oops. For this suburb is below the mean. Assume the areas of these inner suburbs are approximately normally distributed. How many of these 38 suburbs are expected to have an area that is 2 standard deviations or more above the mean? So this is pretty straightforward, guys. We can draw our, so we've got our mean, right? X bar mu, whatever you want to use. And we've got, 1 standard deviations, 2 standard deviations, and so on. You could easily use that table here. So they're asking us 2 standard deviations or more. So that's from here onwards, right? So more than 2 standard deviations is going to be this value here, these values added together. So that's going to be 2.5%. Right? Now 2.5% is 2.5 over 100, but they're asking us to find the count, right? How many is what the question is asking us to find. And then you would have to go on and multiply it by the 38 suburbs that they're saying this country, that this data set has. And what does that give us?
0.95.
0.95 to the nearest is going to be equal to 1 suburb then. Excellent. Cool. All right, so I might pick and choose some questions because I've done quite a few MCQ questions, the last set. We might go and do this extended response question for these ones. So let's have a look at NHD question number 2 here. They're saying that the weight of a species of birds is approximately normally distributed. They've given us the mean, and they've given us the standard deviation. And they've given us a weight of a bird. So we want to calculate the Z-score for that. That is going to be your actual data value, which is 67.9. Take away your 71.5 divided by the 4.5.
Negative 0.8.
Negative 0.8. Fantastic. Now, again, we've been asked to determine the percentage. So please pay attention. Sometimes they'll give you a total and they'll ask you to find a count that's above a certain number of standard deviations. Sometimes they'll ask you to leave it in percentage. So 68, 95, 99.7. So one of the things that you can do is they're saying the mean is 71.5 and the standard deviation is 4.5. So I might just draw a quick line here. 71.5. 1, 2, 3. 1, 2, 3 going that way. And what are they asking? Where's less than 67? So that 67 is going to be falling here because that's 71 take away the 4.5. So going this way to the left, we would subtract the standard deviation. Going this way to the right, we would keep adding our standard deviation. And we're asked to find the expected percentage of birds that weigh less than 67. So that is, you know, the percentage that would be in this part of the bell curve. Now we know that the middle of this one standard deviation here, we said was 68. That means I'm left with 32 for both of these sides. That means I've got 16% for one of them sides. Okay, so the expected percentage is going to be approximately 16%. Cool. So the next question is asking me, so now I'm going to have to rub this off again. What percentage would fall between 62.5, that's going to be this value here, and 76, that's going to be this value here. Now you could go and easily add those values that were in that table. So we know this is 34, this is 34, this was 13.5. Alice, so that's going to be an 81.5 for me. All right, 68, 80, yep, 81.5 over 100. And they're asking the expected number if there were 200 of these birds. So essentially that's just a double of that. And that's going to be 163. Sorry, was someone going to say something? No. Cool. All right. Okay, we might go to question number 6, and I'll use Menti for that one. Can I get you all to attempt question number 6 here? And then we can wrap up mean and standard deviation. So let's go here, close. Back. That's the question. Let's have a look. Here we go. Let's do this one. So if I can get everyone to engage with the question here. So they've given us the mean and the standard deviation, and they're asking the percentage of travel times between 66 and 72. I've got about 8 people that have engaged with the question. I'm just going to wait until we get to about 50. $47, $49, $50. Cool. Cool. So majority of you guys have recognized that it was D. I might go and do this question really quickly for us. So we've been told that we've got 1, 2, 3, 1, 2, 3 going that way. So the mean is a 70. And we've got a standard deviation of 2. So like I said earlier, we just keep adding our values going to the right, and we would keep subtracting values going to the left. And with this, they're asking us to find between 66, which is here, and 72, which is here. So again, we've got a 34%, 34%, and 13.5%, which is essentially 81.5%. And have they given us a quantity? Nope, they haven't. So the answer is just the D. That's going to be our answer. Cool. All right, so we're now moving on to bivariate data. So where we had explanatory and response variables. One way to look at it is Alice, I think you've mixed this one up here. So the response variable is the outcome, right? The response is your y-axis. Apologies, guys. Can we fix that one? Always. So this should be response to the other. Actually, I know what I can do. I can fix this up by swapping these two guys. This is your explanatory. And this is going to be your response. Fantastic. All right, we'll do a few quick questions. Always, you know, your response variable is going to go on your y-axis. So relative humidity is going to be your response then in this case. I'm not going to do too many of these questions with the graphs. Let's have a look at this one. They're saying the lifespan in years and gestation period in days is given. They want to try and predict lifespan to be predicted from gestation. So if lifespan is predicted from gestation, then lifespan is going to be Y, and your gestation period is going to be X. So we know our explanatory variable is going to be the gestation period. Okay, I won't be doing too many questions with that regard because they are so straightforward and easy to recognize. Cool. So displaying bivariate data. So there are several types of graphs that we can utilize to display bivariate data. And you'll notice there's quite a few MCQ questions as well when it comes to identifying this. One thing you need to remember is, so if you've got both categorical data, you could do segmented bar charts or two-way frequency tables. If one of them is categorical and one of them is numerical, you can do back-to-back stem plots, stem and leaf plots, but this is only if you have two categories, right? Only if you have two categories. Majority of the time, we tend to use parallel box plots. And of course, if you've got numerical and they're both numerical, we tend to use, you know, our scatter plots to display that data set. Excellent. All right. Moving on to this question. Quite a common type of MCQ question. So let's have a look at question number 2016, question 1. I'd like you guys to do this and post your answer in the chat, please. All right. Oh, quite a few. I've got a mix of A's and B's coming through. So this might be a good question for us to answer, given there's a bit of confusion. All right, so the first thing to note is these totals here are for the columns, right? And when you read the question, they're asking us the percentage of adults under 50 years of age who have high blood pressure. So we're no longer interested in the entire data set. We're actually interested in the adults under 50 years of age. So that's in this column here. Now we're not looking at this data here, and they're not considered when it comes to, remember when I said percentage was total over total count? So the rest of the table is not considered in this total count. The total count for this is actually the 58, which is the adults under 50 years of age. And then we've got high blood pressure, who have high blood pressure, which is just 11. So we've got 11 over 58 multiplied by 100%. Alice, if you can help me out, please.
Yeah, it's 18.9. B's.
So it should be 19. Okay, so hopefully that was helpful, guys. For those that did answer A, please make sure you're paying attention to this bit of information that they tend to give on each of these type of questions. Oh, all right. So let's find our next highlighted question. Ooh, comparing between parallel box plots. Before I get you guys to do this question, one thing I really want you to try and understand is no matter how lengthy some of these quartiles may seem or how short they may seem, you will always tend to have 25% of data values in a quartile. Okay, so this also has 25%, this will have 25%, and this will have 25%. So that is an important piece of information that you will have to remember when you're doing your exam. Okay, so I'm going to get everyone to respond to this question on Mentimeter. This one here. Ooh, have I cropped off the answers? That's no help. We're going to go back here. That's fine. I'll get you guys to respond in the chat. Please let me know what you think is the answer to this question.
Also, we just got while you're doing that, a question. Ask how rounding works in the exam. So I think this must have been in relation to the past question. When it says is closest to, the answer was 18.9 or 18.8. So obviously in this case, you're going to be rounding up because it's greater than 0.5, but if it's lower than 0.5, you would round down.
Right. All right, team, let's do this question, please. And I'd like you guys to respond in the chat really quickly. So some of you guys are still having a crack at it. So don't get stumped by questions like this, you know, where they say it's not true and you see the first thing that's true and you end up circling that, right? You don't want to be that person. I'm getting a range of answers. All right. I am going to answer this because I feel like I've gotten all the letters in the chat. So we've been asked, you know, which of these statements is not true? Okay. So let's see. More than 50% of the outer suburbs. So first of all, I'm looking at outer suburbs. More than 50% of the outer suburbs have population densities below 2000 per kilometer. So more than. So if it was 50%, that will be, you know, those values. But you can see the 50% is, you know, lower than that 2000 mark, which means there's more than 50% of them that have population, sorry, more than 50% of them have outer suburbs have population densities below 2000. That's correct. More than 75% of inner suburbs. So now I'm only interested in this one. Inner suburbs, more than 75% of them have a value that is below 6,000. Now I go to 6,000, draw the line, right? This makes 25%. Like I said, this makes 25% and this makes 25%. Yes, that is also true, right? Yeah, more than 75% have a population density less than 6,000. Population densities are more variable in outer suburbs than inner suburbs. So, outer suburbs, is the range here more than the range here? So I'm going to put a question mark because the obvious answer seems like it is not, but I'm going to go and check my next set of solutions. The median population density in inner suburbs is approximately 4,400. Yes, we can say that that's true as well. And then the next one saying population densities are on average higher in inner suburbs. Yep. Because when we want to compare on average whether something's greater than the other, we look at their median values, right? So I say, you know, if I've got, I'm going to say this is a median of A and I've got median of B, right? If median of A is greater than median of B, I can say that on average, you know, the values for A tend to be greater than the values for B, right? That's a common sort of assumption that we make with further maths. So this is also true, which means C was the incorrect answer or the correct answer because it's not true. Does variable refer to IQR or range? Good question. Generally, when there is outliers, we tend to compare IQRs, but in this case, you know, if you look at the IQRs, they seem quite similar. These ones, I mean, you could probably do a proper calculation, but in terms of range, when you compare the range here, you can see that clearly the inner suburbs have more variable values. All right. I'm going to move through to some more difficult questions. So let's go on to do some display related questions. So where you have to identify which display you'd need to use. So let's do this question here. So I'm going to get you guys to attempt 2 of the questions. I'll get you to do 2016 question 9 and 2019 question 8. And if you can respond in the chat with your answers to both. It's asking us, you know, when we would want to use parallel box plots. So, oh, I can see some of you responding with your answers. Remember what I said, everyone. You definitely want to work along myself and Alice. You want to be doing the questions yourself. You want to be thinking about them. You want to, you know, eliminate just incorrect answers. All right, I'm going to take this as a cue to get started because some of you guys have already started responding. This is great. All right, so parallel box plots. What we need to remember is one of the variables will be, categorical, and the other variable will have to be numerical. Okay, that's what we would use parallel box plots for. So they're asking us what graphical tool can be used if we've got monthly median rainfall? No, that's definitely a numerical variable. So our next variable will have to be categorical, right? So monthly median wind speed is not a categorical variable. Monthly median temperature is not a categorical variable. We have got month of the year, which is a categorical variable. Nice and easy. I'm going to go and do question number 8 now.
Another quick trick with that one there, if you weren't sure that you needed categorical and numerical, you can just immediately already work out that month of the year will be the correct answer because it's the one answer that's different from all the others. You can see that all the others are numerical. So obviously they're not going to be correct if there's one standing out.
Correct. Good one. All right, so we're going to look at Percy. Percy conducted a survey of people in his workplace, two-way frequency table, attitude towards shorter working days. So that's probably going to be like a 4 against. Yep, like they've said. Then the other variable, we said two-way frequency tables are for both categorical and categorical variables, right? So age in years is, let's use Alice's method. Everything except for the gender or sex as male and female is numerical. So the correct answer for that is going to be B. Well done for everyone that managed to get that answer. Alice, were you taking over?
Yep. Okay, so we're now going to look a little bit more into...
I'm going to stop sharing.
So when we are exploring scatter plots, there are 3 ways to describe the relationship: the strength, the direction, and the form. So strength is either strong, moderate, weak, or no relationship. And usually we can gauge this by Pearson's correlation coefficient, which we'll come to in a minute. But also if they've given you the graph, you can see if all the points are creating a nice line, then it would be strong. Direction, positive or negative. If our graph is like this, that's negative. Whereas if it is going up, it is positive. And then obviously linear or non-linear. So linear would be if all of our points are making a nice straight linear line. If it's non-linear, it might look something like that. You can see that that's not very linear, not a straight line. It would be best suited to something like that. Let's do this question here. So lifespan versus sleep time. And they've given us a least squares regression line and a coefficient of determination. We can describe the linear association in terms of strength and direction. So we can see in terms of direction, it is negative. And in terms of strength, well, coefficient of determination is the same as R squared. So if we want to get from R squared to R, we're going to square root R squared, right? So if we square root 0.416, we get 0. That gives R is the square root of 0.416, which is 0.64. And as I'm about to get to, if we look at our R values between 0.5 and 0.75, which is where this value lies, we have a moderate relationship. So we would say negative and moderate strength. Yeah, so as I was saying, we have correlation coefficient, which is R, and this measures the strength and direction. So just make sure this table is really good to have in your notes. It pretty much tells you what each one is, so you don't have to remember it yourself. But we have all the way from strong negative to strong positive and everything in between. And there's two assumptions that we make, is that the relationship is linear, and that we have two numerical variables. If those two assumptions we make are actually incorrect, then we can't use our R value. Let's do this. Actually, no, we just did. We won't. The other way to work, so there's two ways to work out R. Firstly, you can input it into your calculator, and when you go and analyze the data, you'll be able to get R. That's for like situations like this, when you're given all of the data values, but also if we're given Pearson's the coefficient of determination, or R squared, we can say that R is equal to the square root of R squared, right? But we need to be careful that R is actually equal. When we square root a number, we only will be given the positive answer in our calculator, but we need to then decide whether R is positive or negative. So in that case, you'll have to look at your graph and decide whether it would be positive or negative, right? So in this case, even though I said that R is the square root of 4.16, my calculator gave me 0.64, but the correct answer should be negative 0.64, because we have a negative relationship, right? So if they ask for R, you would have to put in the negative there. So just remember, your calculator will only give you the positive solution, but you need to decide whether it is the positive or negative solution for R. Let's look at R squared now. So R squared is used to explain the variation from one variable because of the other. And it is always positive, negative, never negative, so it doesn't give the direction. And what we calculate it by just squaring our Pearson's correlation coefficient, okay? So it's just the square of that. And the interpretive statement, this is another good thing to have in your notes, and you just swap out what I've underlined in red into the specifics of the question. So let's do an example here. So we have actual temperature versus apparent temperature, and the coefficient of determination is 0.97. Interpret the coefficient of determination in terms of these variables. So what we do is we multiply our coefficient of determination by 100 so that it is in a percentage. So we would say 97% of the variation in, and we look back in the response variable. So that's always on our Y. So in the apparent temperature, can be explained by the variation in our explanatory variable, which in this case is the actual temperature. So that's all you have to do there for the interpretive statements. Just make sure that you, really good to have this in your notes, and you just have to substitute the values that they're giving you. Let's just do this one here. 2018 NHT. So let's go on to Mentimeter. Let show results. And our correct answer should be A, which most people are getting. We have a few people doing E. So let's just have a quick look at it. So they've told us that Pearson's coefficient of determination is that. So what is R? So we're going to square root 0.8689, which gives us 0.9321, right? But as I said before, that whenever we square root our R squared, we're only given our positive answer in the calculator, but we need to decide if it's positive or negative. If we look at our equation of the regression line, we can see that we have a negative gradient here. So that means that we have our slope will look like this. So that means that the solution that we want is that R is the negative answer. So negative 9.321, which is A. Let us move on to correlation and causation. So we're just going to quickly go through this, but pretty much just because there's a strong relationship between two variables does not mean that one thing causes something else to happen. So let's say there's a strong relationship between the hours that you study and your ATAR score. We can't say that because you study for longer, you will definitely get a better ATAR score. But the right thing to say is that a student that studies for longer will likely get a better ATAR score. So there is a correlation. It's not causation. So there are a few examples of when there is a non-causal reason for this correlation. So like it's not, So there's common response, confounding, and coincidence. So common response is when the two variables are associated, but not because one causes the other, but there is a third variable that they're both strongly related to. So for instance, lifespan of people in a country and education level, they are probably, the third variable is probably wealth, right? That might be the common response. Confounding is pretty similar, but rather than there just being one third variable, there's lots of different variables that can influence the association. And coincidence is there is an observed association, but there is no obvious link. So it's just a pure coincidence that those two have a relationship. So the example here is there's an association between heart disease and number of lakes. Obviously, they're not actually related to each other. There's just a coincidence that they seem to exist. Often these won't actually appear on the exam, but definitely worthwhile having in your notes book because they might ask. So we'll just do a quick example here. This one, there's a strong positive association between Human Development Index and carbon dioxide emissions. It can be concluded that increasing carbon dioxide emissions will increase the Human Development Index. So by using words like will, they are saying that it does cause it. So we always want to steer away from using such strong words in our analysis. We want to be using words like may or likely. So from that, I can immediately eliminate A. B, decreasing, same thing, it's using will, eliminate. C, this association must be a chance occurrence and can safely be ignored. Yeah, maybe. We'll see if we have a better option. Countries that have higher human development indices tend to have higher levels of carbon dioxide emissions. Yeah, possibly. And our last one is wrong because that's saying that it's a negative association, but we have a positive association, right? So now we're deciding between C and D and looking at these variables, Human Development Index and carbon dioxide emissions. There's probably not, if we look back at our reasons, they're probably not really related. So I would probably go for C in this situation. Let us move on to the least squares regression line. Actually, no, sorry, we're going to have a quick 10-minute break. We're going to have a 10-minute break until 11:10, but we just have a quick 12:10, sorry. We have a quick video to share before we go to break.
Hi, my name's Emma. I work on the equity sales desk at UBS, focusing on hedge funds. My biggest career highlight to date was hosting a panel with over 150 clients who were based around the globe with one of my colleagues a few weeks ago, presenting on one of my pieces of work. At university, I studied commerce with a focus on French, data science, and finance. And in high school, French was one of my favorite subjects. Advice to my younger self would be to make the most of your youth and just ask as many questions as possible, really leveraging the fact that you don't need to know all the answers. All the best with your studies.
Hi, my name's Sahaj and I'm an investment banking analyst here at UBS. So basically, I work with the team to advise our clients on making important decisions, such as how to use their resources most efficiently, how to grow the business moving forward. Is it a good time to sell a part of the business? Is it a good time to maybe buy another business? So we help them with these decisions. What I've particularly enjoyed in my short time here at UBS so far is the opportunity to work for some pretty big companies that I'm sure we all deal with on a daily basis. So I think it's really cool to be a part of something like that. So during VCE, I particularly enjoyed math and commerce subjects. So I studied maths methods and specialist maths. And for the commerce subjects, I did accounting and economics. I was really interested by what I learned during VCE, so I wanted to pursue it further. And that's why I studied commerce at the University of Melbourne. That's where I learned about finance. I involved myself in a lot of university societies, and that sort of sparked my interest in investment banking and the work that we do here at UBS. Some additional advice from my end is always to be curious and to not settle for things. And whether that's with your career path or what you might want to study in the future, make sure that you're always trying new things and opening your minds to everything that's out there. I guess VCE is just one chapter of what can be a pretty long story. So whether you perform exceptionally well or not in a couple of months' time, remember that you still have the rest of that story to write. My advice to myself, if I was doing VCE again, would most definitely be to zoom out and always take a look at the bigger picture. You've probably heard something like this before, but high school's a very unique experience, I think. It's definitely one of the last opportunities for you to spend almost every day with a majority of your friends all around you. Make sure not to get so consumed by VCE that you forget about what's otherwise a really special year in your lives. Don't forget about your passions, your development as a person. So trust that you've put in all the hard work for your VCE exams, give it your best shot, but look forward to the life ahead and everything else that's exciting in your lives.
Okay, let's get started again. So we are running a bit short on time, so we're just going to get through a bit of content now and then hopefully have time for a few questions. So as we were looking at, we're continuing on with scatter plots, and we looked a little bit at least squares regression line before, but we're going to continue. So when we have a scatter plot, we have all the data points and we can calculate a regression line, or in this case, a linear regression line, to be able to predict the value of one variable from the other variable. So we calculate the regression line by reducing the sum of the squares of all the y values. But you don't need to know how to do that. Your calculator does that for you. The only thing that you do need to be aware of is how to calculate the gradient or the slope and the intercept from a few variables. So we have that our linear regression is y equals a plus bx, where b is the slope, and that's given by r multiplied by the standard deviation of y over the standard deviation of x, as you can see here. And the intercept, which is a, is the mean of y minus b, or the slope, times the mean of x. So they are two equations that I would definitely be having in my notes book. I don't know about you, but I definitely cannot remember these off the top of my head. So having them in my notes book to quickly flip to is definitely a good strategy. The next thing with linear regression lines is that often you're asked to interpret the slope or the y-intercept. So another thing to have in your notes is these statements that you can just input the specific values and context from the question into. So for the slope, we say that for every 1 unit increase in whatever the explanatory variable is, you can expect the response variable to either increase or decrease, depending if it's a positive or negative slope, by b, which is the gradient, and then make sure to put in units. And similarly with the y-intercept, we say that when the explanatory variable doesn't exist, or when the explanatory variable is equal to 0, we can expect to have a, which is the y-intercept units of the response variable. So we'll do a few examples of that later. The other thing is that often you might be asked to predict from the least squares regression line. So there are two things to take in mind when we are predicting, is that they might ask you if that prediction is reliable. And what we have is that, say these are all of our data points, right? And we've created a regression line that's here, but our data values are only kind of going from here to here. So anything within our data value range is what we call interpolation. So that's within predicting data values within the data set. And this is a reliable prediction. But anything outside the data set, so that would be from here onwards or from here onwards, is what's called extrapolation. And that's outside the data set, and that is quite unreliable. So if they ask you if it's a reliable prediction, just ask yourself, is the data value within the data set, or is it outside the data set? And then the reason for that is either interpolation or extrapolation. And so let's do this question on Mentimeter. We have a scatter plot and we're told that R is 0.8616. What is our least squares regression line? So we only have one answer. Oh, two. Only 6 people, come on. Give 15 more seconds and we'll go through the answer.
Alice, I think the voting has been closed for some reason.
There we go, that should work. Sorry about that. Okay, let's have a look at so the correct answer should be B. We're getting a lot of people saying C. So let's go have a look at the answer. So this is a bit of a trick question, but what we know that y equals a plus bx, right? Where b is our gradient and a is our y-intercept. And a lot of you did C, where you did 7.4 has the intercept, which looks like it's correct, but you need to be really, really, really careful with the axes, because you can see here on our x-axis, we're not starting at 0, we're starting at 7. So even though this is where it's going through the y-axis, the y-intercept is when x is equal to 0 or length is equal to 0. And in this case, here, this is where length is equal to 7. So that is not our y-intercept. So immediately we can already rule out D and C because of that. Then we need to calculate our gradient, right? So we can just choose any 2 points. So maybe here we have 10, 9, and here we have about approximately 9 and 8.5, right? So our gradient is going to be 9 minus 8.5 over 10 minus 9, which is about 0.5 to 1. So it's approximately 0.5. So that means it's either B, or that leaves us with B and E, because A is wrong. Then we look at B and E and they're the same, but they've just got the variables switched around. So we want to make sure that width is our Y variable or our response variable. So that leaves us with the answer of B. So this one, really important just to look at the values on the x-axis. The other one, this is a very common question, is drawing the least squares regression line on the scatter plot. So the way to do this is that we need to find 2 points on in our least squares regression line and connect them. So often easiest to do the start and end point. So in this case, let's do when head length is 52 and when head length is 60, right? So we say that negative 24.83 plus 1.739 times 52. And that equals 65.589. So if I put, that will be about here. And then always important to label it. So label the coordinates 52, 65.598. And then let's do, I said 60. $79.51. That's about here. And then just using, you would use a ruler, connect the 2 dots. I'm getting a lot of questions about if you need to label the points. Yes, you do need to label the points. Otherwise, they might not be able to know if your line is accurate and you have already worked out the points. So for an extra 2 seconds it takes to write the coordinates, I definitely think it's worth it. And someone asked about using points within the data range. It's fine in this case because we're using the least squares regression line. We're not making any predictions. We're trying to draw the least squares regression line. So you can use any points you want. It doesn't have to be in or outside the data range. Just any 2 would be fine. Let's do another Mentimeter question. I think I'm missing the statistics. They're over here. Hopefully that, yeah, I'll keep my statistics up on my screen and then you should have the question on your screen. I'll give another minute. Okay. Stop it. So A is our correct answer. So let's work through it. We're finding on average for each additional cup of coffee drunk, the amount of sleep. So this is asking us to find the gradient. So our gradient for B is equal to R times SY over SX. Coffee is going to be our X and the amount of sleep is our Y, right? So we're saying that negative 0.77 times SY, which is sleep, 1.12 over 1.56. And that should give us 1.12. And that gives us an A, decreasing by 0.55. Cool. Let us do question 5. Use the equation to predict the weight of a bird with head length 49 millimeters. So when we're predicting a value, we're just substituting the value of head length into our regression line. So in this case, we would say negative 24.83 plus 1.739 times 49 equals, and we just put that into our calculator. Minus 24.83, and we would get the answer of 60, and we're doing to 1 decimal place, so this is 60.4. And then always make sure to use units. So this would be in grams, be the weight. Let's just do part A, where we're interpreting the slope. So like I said before, we have our interpretive statement ready to go. We just substitute our values in. Interpreting the slope, we have our slope is 0.8894. So we could say for every 1 and then units increase in pressure at 9 a.m. you can expect 0.8894 HPA increase in pressure at 3 p.m. So key things you can see for every increase, making sure I'm using units. Then we have explanatory variable, gradient, and then response variable. This is one of the extrapolation versus interpolation questions I was saying before. And it's asking us to predict when it's 1025, right? And if we look at that 1025 is within our data range. So we would say that it's an example of interpolation. Moving on to residuals. So residuals they show us how far apart our predicted value and our actual value are. So the equation is actual minus predicted gives us our residual value. And we can then create a residual plot, which is on the y, our residual value versus the x value is still the same as our original plot. And we can see if a linear relationship exists based on the patterning of our residual plot. If there is a pattern or non-random scattering, we would say that our data set is non-linear, whereas if it's randomly scattered, like in this first image, then it is linear. A positive residual means that our points are, our actual value is higher than our predicted value, whereas a negative residual is that our actual value is lower than our predicted value. And a zero value of our residual means that our actual and predicted are the same. So let's go and do this long answer. So they've given us the regression line, determine the residual value when the temperature is 11.2 and humidity is 68. So they're telling us that this 68 is our actual value. We need to work out our predicted, and we do our predicted value sorry, we can do our predicted value is equal, we substitute our temperature into our least squares regression line. So the predicted value will be equal to 136 minus 4.38 times 11.2. $86.94. Perfect. So now our residual is equal to our actual minus predicted. So that would be 68 minus 86.94, which is negative 18.9 to 1 decimal place. That's our residual. It's negative, so that means that our actual is lower than our predicted. And you can see that 11.2, this is represented by this data point here. So you can see how it's below the line. So that means that it is lower, our actual value is lower than our predicted, because our predicted value is on the regression line. And then they've given us the residual plot. Does it support the assumption of linearity? And yes, it does, because it's randomly scattered in the residual plot. So that is pretty much residuals down.
Alice, just before you move on, there is a question in the chat here. I think it just picks up that last point you raised. And Adrian's answered it, so I think we can move on. Perfect.
Cool. So now we're going to move on to transformations. So what happens is if our, let me see, if our residual plot highlights that we have non-linear data, we want to transform this data to make it linear so that we can investigate the data and make predictions from our regression lines. And if the data is non-linear, we can't use a linear line to make predictions from it, because we're not going to get very accurate predictions. So what we do is we make our transformations. So we have a few different transformations. We have the squared transformation, log transformation, and a reciprocal transformation. So squared is either x squared or y squared. We have log, which is log x or log y, and then we have a reciprocal, 1 on x or 1 on y. Pretty much we use our circle of transformations to initially decide which transformations are possible. So if our data is in this quadrant of the circle, so it's increasing and then slowly plateauing, we can use y squared log x or 1 on x. If it is in this quadrant of a circle, we can use x squared or y squared. This one, log y, 1 on y or x squared. And then the last one, log y, 1 on y, log x or 1 on x. So that's how we can initially decide. And then ultimately, the best transformation is the one that gives us the highest R squared value in our when we analyze that data. So that's how we're going to pick our best transformation. But often in an exam, they'll give you the transformation to use or just ask you which ones are possible. So then you can just list the possible transformations. This is good step-by-step instructions for you to go back to on how to use your calculator in the transformations. So pretty much what we do is we put in our original data set into lists and spreadsheets on both TI and ClassPad, right? And then you make the transformation. So then you either like do the squared, reciprocal, or log transformation to the correct value. So whether it's y or x, you can do that, and then you would construct the scatter plot with the transformed data and the other. So maybe you did the log x was your transformation. You would then do a scatter plot of log x versus y, right? And then you can calculate a linear regression line for log x and y. And then you can use that regression line to then make your predictions. These steps in your slides show you exactly how to do that if you're still not sure how to do that. We'll do an example question. So in this one, we have speed versus distance. And I think you can see that the data is non-linear. It's not increasing straight like that. It's kind of curving upwards. So if you looked at our circle of transformations, you can see that it is in line with this quadrant here, right? So we can do log y, 1 on y, or x squared. They're telling us that they've used a squared transformation on speed. So that is x squared, I guess. The least squares line is then fitted to the transformed data with distance as the response variable. The equation of the least squared regression line is. So on a question like this, you can, the first thing to do would be to eliminate any incorrect responses. So we want, we want speed squared, right? And speed is our x. So we want it to be distance equals something speed squared. So we can already eliminate E and D because of that. So now we just have to work out our regression line. So you would put those data values into your into your spreadsheet. Do you want me? should I?
Do you wanna share yours on for the class pad, and then I'll go over the TI Inspire?
Yeah. Class pad. So we go menu, statistics. So we put in our original.
I'll read the values out for you if that's easier. Oh yeah, you've got it next to you. Perfect.
And then list 2, original distance. And then now in list 3 down here, we're doing speed squared, right? So we're going to say that is equal to list 1 squared. And then that will square list 1 for us. And then we're going to calculate regression, linear regression. Our X list is now list 3 because that was speed squared, and our Y list is was distance, which is still list 2. We click OK and we get our regression line, which is telling us that our A, or our intercept, is 0.092. So we can say then that C would be the correct answer. Adrian, do you want to show on TI?
Yep. Will do. So I'm going to go through the same steps using the TI Inspire. Alice, can you give me a thumbs up if you can see my cat?
Yeah.
Cool. So all I've gone and done is, on list and spreadsheets. Hopefully you guys are comfortable adding this to your list and spreadsheets by now. I've entered the 2 columns. I like to label my axes with, whether or not it is the X or Y axis as well, because I find it a lot easier that way when I've got multiple data values for all these different questions. So the first thing that we want to try and do is, Alice, was it speed that we wanted to square?
Yes.
Yep. So I'm going to say SX squared, right? So because I'm going to square that value. And what we can do is we can use this second row here to generate the new set of data values. And what you want is, in your variables, you want to select the variable that you want to square, which is the SX variable. And then you can go and square it. So you will notice that the equation that you plugged in is actually in that sort of bar at the bottom. And that gives you the new set of data. I like to go on to my normal calculator when I'm doing my statistical analysis. So I go menu, statistics. I want to do a stat calculation. And what I want to do is I want to calculate the linear regression equation for it. Now my new X list is actually the squared X values, and my Y list is going to be my distance still. I press enter and I end up with this equation, if you haven't plugged in any values incorrectly. Oh, Alice, are we good?
Yep.
I'll hand it back over to you.
So let's do one more transformation. Let's do this question here. So part A is asking us to round three significant figures, right? So we're currently, if you can have more than, we have 1, 2, 3, 4, 5 significant figures at the moment. So if we wanted to round this to 3, it would be 0.00854, because we know that these zeros here are just placeholders and they don't count as significant figures. So here we have 3 significant figures. Perform a log 10 transformation and write the values for intercept and slope. So if I put these values into my calculator again. We get, also in this case, you can see that it's in years, right? So probably best to just, rather than saying the year, like 1990, you can just change it to be 1990 would be 0, and then the next one would be 20, 10, 10, oh, like 20, 30, 40, so on, if that makes sense. No.
You want me to read the values out for you?
Yes, please.
All right, so, oh, you closed it. All right, what question were we looking at? Yep. So which one are you doing? Yeah.
Mm-hmm.
Cool. So 1990. 1910. 1920.
I feel like it might be meant to be.
Have they asked us to use
just
different data values? No, they haven't.
Seems weird. 1990.
Yeah. So 1930, 1940, 1950, 1960, 1970, 1980.
I think
that looks really odd. You're right. I think that might need to be 1900. Yeah.
66,
66, 80, 100, 120, 160, 190, 210, 240, and 340.
And then they've asked us to find log 10 of area. So that is a log y transformation. So I'm going to put in here log 10, and my area is in list 2. Enter, calculate regression, linear regression, X list is still the same, and my Y list is now list 3. Okay, and I get that my intercept is -14 point, and it's asking me to 3 significant figures, so I'll do -14.4, and my gradient is 8.54. 8.
That's 10 to the power of -3. So you would need to put 0.00. Yeah. Oh, yeah. If you want to do it like that, that's fine.
Then they're asking us that it predicts that we'll have approximately 2.85 by 2020. Using the value, calculate the expected area of the forest that will be eaten by the caterpillars. So it's saying that the log area is 2.85. So we have to convert this into not in log, but yeah, get rid of the log, right? So if we're saying that log 10 area is equal to 2.85, we can say that 10 to the power of 2.85 is equal to area, and so that is equal to
about 2.85. 707.95 nearest hectare, so 708.
8 hectares. And give a reason why this has limited reliability. We're looking at year 2020. You can see that that's outside the data set. So we would say that it has limited reliability due to it being extrapolation. Let's move on to time series now.
Yes, I think we should probably look at the last component of time series, so the seasonal adjustments, because the initial bit's relatively straightforward. So let's jump into, yeah, this bit.
Yeah, so seasonal adjustments is like, you guys can look at this in your own time, but we have smoothing, right, which is to reduce the heights of the fluctuations to make the data more linear, because you can see in time series it's quite all over the place. It's not as easy to follow trend. So we want to reduce these fluctuations so we can more easily make predictions. Deseasonalizing data and seasonal adjustments is similar to smoothing using mean and median smoothing, but it involves seasonally adjusting it. So for example, if you're looking at a shop's ice cream shop's income, they're most likely going to make more money during summer than they are during winter. But that is probably due to seasons, right? So we want to adjust this data for the season so we can have a look at an overall trend over the years rather than just looking at the effect of seasonality. So the first thing that we have to do this is we have to calculate a seasonal index. So in order to calculate a seasonal index, we have to find the average of the mean value from each year, and then you use the actual score for that season and divide it by the average for that year, and that would be the seasonal index. And where you have multiple years with lots of different seasons, to find the seasonal index for a particular season, you find the average of all the seasonal indices for that season, right? A seasonal index that's higher than 1 means that the sales in that season were higher than the average, whereas a seasonal index below means that the sales or whatever were lower than the average. And remember that when you add up all the seasonal indices from 1 year, it will equal the number of seasons in that year. So if the question is depicting seasons as months, for example, there's 12 months. So if you added up all the seasonal indices, you would get 12. Whereas if it's like spring, autumn, summer, winter, there's 4 seasons, so you would get 4. So let's have a quick example here. The seasonal indices for the first 11 months of sporting equipment are shown here. Seasonal index for December is. So there's two ways. In this case, the only way to do this would be to do 12 minus all of these seasonal indices, right? And then that would give us this seasonal index that we don't know. So if we do 12 minus 1.23 minus 0.96 minus 1.12 minus 1.08 minus 0.89 minus 0.98 minus 0.86 minus 0.76 minus 0.95 minus 1.12. I think I missed one. And you should get 1.29. So when you minus all of them, so that would give B, right? And you can see that once you add up all the seasonal indices for that year, it equals 12 because there's 12 seasons. The next part is in May. So we haven't gotten to this yet, but this is deseasonalizing. So I come down. Here. We have a deseasonalized value, which is equal to our actual value divided by our seasonal index, right? And that tells us that is like removing the effect of seasonality. So in this question, May, they've given us the actual sales and they want us to find the deseasonalized sales. So our seasonal index for May is 0.89. So our deseasonalized is going to be equal to 213,956 over 0.89. Which is equal to 240,400. So that is B. This is a multi-choice from last year's exam. They're asking us to correct for seasonality. What does our actual rainfall need? What do we need to do to our actual rainfall? So in March, you can see that our seasonal index is 0.741, right? So that means that our sales in March are typically below the average sales. So in order to correct for seasonality, what we do is that we go 1 minus our seasonal index over the seasonal index times by 100 will give us the percentage that we have to correct. So in this case, that would be 0.259 over 0.741. Gives us 35% if we go to the nearest number. So that means that we need to increase by 35% because our actual value is below. That's why our seasonal index is below 1, right? So we need to increase our actual value. So we're going to increase it by 35%.
Alice, we probably have time for maybe one more question before the break. And then when we come back, we'll get started with financial.
Let's do question 15. So last Tuesday, 108 meals were served and the deseasonalized number of meals is closest to. So do you guys want to send in the chat what you think the answer should be? Okay, I'm getting mostly E's, but a few other letters. So let's just go through it. So remember that our deseasonalized equals actual over seasonal index. So our actual was 108 and our seasonal index for Tuesday is 0.71. Which equals 152. So that would be E.
Someone's asked us whether we could do the question number 16 as well. Alice, I think it's worthwhile because we've got two unknowns here.
Yeah, sure. So if we have, what does the deseasonalized value actually tell us? The deseasonalized,
I can grab that one.
Yeah.
I'll type it in the chat for Elizabeth.
So if we have these two unknowns, right? We know that our total of our seasonal indices has to add up to 7, right? But we also know that they've given us the long-term average for each day. So I think the best thing to do would be to work out the average number of meals. So what we're going to do is add up all of our long-term averages for each day. So we do 89 plus 93, 10, 132, 145, 190, 160 divided by 7. Is 131.28. 6, and then remember that our seasonal index is going to be equal to that value divided by the average. So for Saturday, it's 190 divided by 131.286.
What was it? 190 divided by?
6, which is 1.45. So the answer would be D. So in ones like this where you have two unknowns, you can't do the 7 minus all the seasonal indices because there's 2 that we don't know, obviously. So you have to find the seasonal index with this strategy here.
Alice, I'll let you play the clips in a moment, but great work, everyone. So it has been a long first half in terms of a session. Before you guys go into your lunch break, I just want to say it's probably a good time to stay away from the screens for about half an hour. Over here, it looks nice and sunny outside. So if I were you, I'd grab a nice glass of water, do some jumping jacks, go for a walk, and get back here sharp at 1:30, nice and fresh for even bigger second half of financial maths. Yeah, that's it from me. Alice, did you have something that you needed to play? No. Cool. All right. We'll see you guys back here at 1:30.
Okay, welcome back, everyone. We just have a few videos to show before we start the finance section.
Something happens when we feel really stressed, like borderline anxious. Something happens in our brain that, unless you know how to deal with it, it's actually one of the places where our brains actually totally hold us back. Like they make things stacks worse than they actually need to be. So in this video, I'm gonna share what actually happens in our brain so that you get what's going on, but then also share something you can do, like a little hack you can do that's super simple that you will always have. Like once you hear it, you'll always have it, you can always use it, that helps you override some of the default stuff that our brain does that literally, gosh, I mean, our brains are amazing, like totally extraordinary. Like, it's hard to believe that in some ways it completely holds us back and has us feel horrible and completely overreact during things like, taking an exam or asking someone out or public speaking or being in an interview. You know how stressed out you can feel about that? And logically you go, that makes no sense that I'm that stressed. Like, what's the worst that can happen? But in your body, you're completely freaking out. So when that stuff starts to happen to our bodies, when we're worried about something, it sends a signal to our brain that it needs to protect us. And the problem with this is that the signal it sends is that it needs to physically protect us, like we're in some kind of physical danger. So what it does is it sends a shot of stress hormones like adrenaline to our body that has us get into the mode of being able to either run away or stay and fight. So fight or flight. It gives us fight or flight chemicals because it thinks we're in physical danger. And normally we're not. We're like either really worried that she's gonna say no, or we're like worried that we're gonna fail an exam, or we're not gonna do well in an interview. But we get these stress chemicals that have us like seriously, like we're pumped up to fight or to run away. And that's the last thing you wanna experience in your body when you're just about to do something that has you need to be in your head. Because you actually can't be in your head when you've got those chemicals running through you. They actually shut down your brain. Like your mind wants you to be 100% focused on your body and using it to either run away or stay and fight. So it doesn't want to spend any energy in your brain thinking through things. Like that's the last place it wants you to spend energy. So you literally, like you can fully go blank or just forget stuff and go, what happened to me there? So here's what you do. You simply have to say something to communicate to your brain why you're feeling stressed. It sounds corny, but you have to say, you're okay, Leah, you're gonna be fine. You're just stressed because this is really important to you. You are safe.
All right, everyone, welcome back. Hope you guys have had a good lunch break. We have got a packed second half for the day, and we are going to do one of my favorite topics, which is the financial maths module of the exam. And the first bit of content that we have is around recurrence relations and their rules. So recursion basically means repetition, right? Like we see the same thing happening over and over again, and we tend to use recurrence relations to describe a couple of financial scenarios. And we've got, you know, quite a few different rules that we need to try and remember, or we will end up using in the exam. And Alice has done a great job in, you know, outlining all of this for you in this table here, right? So hopefully you're, you know, familiar with all of this, and you've had a chance to attempt these throughout the year. To begin with, we're going to start off with this question here, which only 20% of the state got correct. So Ray's deposited, you know, 5,000 into an investment account, earning interest at 3% per annum, it says, compounding quarterly. Now, it's super important that you pay attention to how often something compounds. Okay, how often something compounds. And they're asking us to find the rule Rn. Now, Rn is going to be your initial value, right? Oh, I can see some of you guys are responding. Now we've got our initial value, which is 5,000. Now, with the rate that we need to have, or capital R, right? In the equation is normally 1 plus the rate over n over 100, because you have to consider how often something compounds. So in this case, we can say 1 plus the rate is 3% per annum. However, it's compounding quarterly. So we've got to divide it by 4 because we want to find how much it's going to compound per quarter. Okay, divide by 4 over 100. And then if it's after n years, you can't just say n here, because you must remember that you're going to have 4 quarters. Sorry, what are they after? After n years. Yeah, so we got 4 quarters. Therefore, the answer should be, folks, what have we got? Let's have a look. Ooh, we've got mixed values here. It should be E, right? It's not this, it's not this, it's not this, and it's not this. It's got to be E, because 3 divided by 4 is, you know, 0.75 over the 100 is going to be 1.0075, and then 4 times the n. Okay, it's a good question to note, and as you can see, only 20% of the state got it correct. Okay, and that's the reason. The reason being, you need to recognize that you've got to divide by n, and you also need to multiply the n here, because n here is referring to year, right? And you've got 4 quarters per year. Alrighty, cool. Moving on to this question here. Alice, please note and let me know when you want me to jump a few questions given our time constraints. All right, so we've got question number 29. We've got a scenario where a certain vehicle is depreciated by K% per annum using reducing balance, okay? And then they're saying after 3 years of depreciation, it is depreciated in the 4th year under unit cost method at 15 cents per kilometer. 15 cents per kilometer, okay. The value of the van travels 30,000 kilometers in the 4th year. Hang on. Okay, this one, value of the van is purchased, so 45,000. K% of reducing balance. So what's that saying? 45,000 times 1 minus K over 100. Okay, after 3 years gives a certain value. It is depreciated in the 4th year under unit cost method at 15 cents per kilometer. Okay, the value of the van after it travels, okay, cool. So we got to check what the value is going to be before it traveled 30,000 kilometers, right? So what's that? 15 cents per kilometer times, Alice, can you help me out here? So 15 cents times the 30,000 gives me, that should be 450. Is that right?
Yeah.
Yep. And then I've got to add that to this value here because that is how much it would have been. So how much is that? 26 what's that? 6, 16, 24. And then I can go menu algebra solve. Folks, what do we have for K? So maybe I might show a timeline. What they're saying was you've got from 0 to 3, they went at K%, right? And then they use unit cost, right? And apparently after 30,000 Ks, right? After 30,000 Ks at 15 cents, right? At 15 cents, the new value after 4 years was 26,166.24. So what I had to do was I had to go and backtrack and identify the value at the end of 3 years. Ooh, have I made a mistake? Oh yeah, 30,000. Apologies. So that should be 4,500. Sorry, Alice, can you whack that on the CAS for me? What's happening here? 4,000. No, 30,666.24. Thank you very much, Maria and Yuval. So what do we end up with K for K, guys? Come on, team. Let's do this. Oh, if I get another confirmation, brilliant. All right. So we might have a look at this question here. I'm getting a lot of engagement in the chat. So yeah, we can. So Samuela has asked me whether we could use a solve function in the CAS. Yes, we can. So we can say solve and solve this equation and tell me what K is. Okay, no issue at all. All right, let's have a look at this question. They are saying the purchase price of a car was $26,000 and they've used reducing balance and it's depreciating by 8% per year, right? So this is crucial, right? Reducing balance. If it is reducing balance, it's not 1 plus R, it'll be 1 minus R. It's not going down by a constant value. It's not unit cost, And then it is not a mixed scenario. You can just eliminate a lot of the answers. Okay, like I said earlier, some of my strongest students in the past have managed to complete the MCQ questions with about half an hour to 45 spare. Okay, because you can eliminate a lot of solutions. But yeah, keep in mind, you don't get marks for finishing your exam first, right? You want to get them accurate as well. Just trying to show you that you can really eliminate some of these solutions and save up a lot of time. Cool. Now, it's really important that you're able to recognize, these different graphs as well. Alice, have we got a table of graphs? Probably not. So I might just go over this really quickly. So we've got, flat rate depreciation. Flat rate dep is going to look like this going down. So it'll look linear. Reducing balance depreciation. Reducing balance will look like this. So the amount that it goes down by, or the amount that it depreciates by, keeps reducing, right? So that's why the curve will take that shape. We've got simple interest investments. Right, which will appear to be linear, and then compounding investments will appear to look like this, because the amount of interest that you accumulate over time will keep increasing. Okay, cool. Now, this question here is around a perpetuity, right? If you guys can remember, right, when it comes to a perpetuity, we're going to learn these scenarios a little bit later because I've got a nice table that I want to run through. But for now, maybe just pay attention to this bit. The value of a perpetuity does not keep changing. Okay, it will infer the maths anyway. What we receive in terms of payments at the end of each pay period is the amount of interest that you have earned. So for this question, where they're saying, and obviously you want to pay attention to these y variables as well, because I've seen them play around with the y variables quite a bit. Okay, So if they say, because they've said the value will remain at 80,000, right? Now, if that said payment amount, your Y variable should be 4,000. Okay, so please make sure you're paying attention to your X and Y axes whenever you're given a question that has a graph. Cool. All right, we might look at question number 5 here. So I'm going to give everyone 1 minute to get started. Read the question. And I'll get started afterwards. So it's 1:44. Cool. So this scenario is a snooker table. They've got a snooker table that's depreciating using reducing balance method. And they're saying the value of the snooker table after a certain period is 2,760. After 1 year is 2,750. After 2 years, it is $2,539.20. So to show that the value of depreciation is 8%, right? All you need to do is you want to find the value it has gone down by, so depreciated amount over the original amount for a period multiplied by 100%, right? So in this case, it's gone down by how much is that? 240. 240 divided by the 3,000, and we want to multiply by 100%. And that should essentially give us 8%. So we have shown that the annual rate of depreciation is 8%. Now we've been asked to write a recurrence relation, okay? One of the common areas where folks make mistakes is they forget to write the initial value when it comes to a recurrence relation. Now, in this case, you can see that the initial value, or the value that it was purchased for originally, is 3,000. And then we know our next term is going to be 0.92 times our current term, right? Yeah, each time you want to find the next term, that's going to be 8% less than the previous term. And this value here is 1 minus R over 100, where R was actually 8. Okay, so hopefully you guys are comfortable with that. Cool. Moving on. I'm going to have a look at this graphing question, although I haven't highlighted it, because I know it's these graphs and questions like this that majority of the students find difficult. Okay, someone's asked me, does it matter which letter you use S and my teacher used T? Okay, that's a good question, right? So Alexis, in this question, they're actually asking us to use S. Okay, I didn't use S because I preferred S. When they've outlined and they've said in terms of Sn plus 1, then you've got to use Sn plus 1 because you'll be penalized if you use T, and because that's not what the expectation of the question is. Hopefully that answers your question. Brilliant. All right, team. I would like you guys to have a crack at question number 22, please. Let's use the chat. Like I said earlier, the best way to get the most out of this session is if you engage, right? Reason and see if you understand what's going on here. And yeah, post your answer in the chat, please. All right. Hang on, someone's asked me, could you please go back to the question just so I can take a photo? Does that help, one Chika? Is that all right? Oh. All right, so with that second question that we've been doing, this graphing one, we've got quite a few of you guys saying A's and B's. All right, so How do I differentiate between these two? So first of all, we know it is a depreciating scenario because the value is going down, right? So I'm going to eliminate compound interest, perpetuities, and annuity investments. Okay. Actually, sorry, I should say I can eliminate annuity investments because they're talking about additional payments made into the account. Okay. Because some annuity investments might look like this as well. So, but because it's saying additional payments made into account, I'm going to eliminate that. Now, earlier on, I said I can easily identify what the graph is by looking at the nature of the dots, right? Or the nature of the plot. If it is looking like a linear decline, it is flat rate. But if it is looking like a curved decline, it is reducing balance. So the answer, or the correct answer for this, is going to be B. Okay. Like I said earlier, folks, we've got quite a few questions for you. The good thing about this worksheet is it's compartmentalized all the different concepts that you're going to get assessed on. Let's say, for instance, you want to find out where the solutions for this question is. All you've got to do is make sure you download all the VCA exams, put it into one folder, and go and search up 2018 NHT. In 2018 NHT, if you just search out the word Rosling, that should come up. Okay, so in the reports, right? Or if you search up question 7, that should come up. So it's a good way to have everything in the one place for you in terms of the style of questions that they ask. I'm going to go back to this MCQ question here. I might actually do this one. So first off, we've got this guy, Marty, who is depreciating the value of his car and he's using flat rate depreciation. Okay. Now, after the 3 years, apparently the value of the car is halved. Okay. So this doesn't indicate that. I'm going to go and eliminate that straight away. Okay. This looks like the value of the car is constant. So I'm going to eliminate that easily as well. Then what's happening is Marty is going to continue to depreciate the value of the car by the same amount each year after the incident, right? So what we need to have is we need to have consistency in these two sets of lines. If you look at this here, in terms of steepness, the steepness has changed. Isn't that right, guys? Right? The steepness has changed. So that is not the answer, right? Because they're saying he's going to continue to depreciate it using the same amount. Now with these ones, that looks strange because it doesn't look linear, right? This dot appears to be out of that linear line. So I can eliminate that as well. My answer should be a easy C. Okay. Cool. We might do a worded problem. Let's do this one. Question number 9, please. Okay. I'm going to give you guys one moment to have an attempt. So perhaps, on your piece of paper, jot down the equation that you think it's going to be. Very common kind of question, guys. As you can see, this is from 2019, right? That was 2 years ago. Okay. Cool. I might go and do this question now. So Phil has purchased or is borrowing to make a purchase, and he's borrowing $350,000. Supposedly after paying 4% per annum compounding fortnightly, and having done that for 3 years, he's got this new balance. And now it looks like the scenario changes, and over the next 4 years, right? That's after the 3rd year. So from year 3 to year 7, Phil's making these payments and will still continue to be paying this much interest compounding monthly now, right? So over here, they said fortnightly. If you didn't read the rest of the question, you're going to be in trouble, right? So Alexis, they've asked for B in terms of B0, right? So I'm going to say B0 here is my new value at the end of the 3 years. So that's going to be $262,332.33. Okay. And my next term, or Bn plus 1, is going to be, I need to find the rate, right? So find the rate, I'm going to have to say 1 plus the rate is at 4%, 4.8% per annum. However, it's compounding monthly. Therefore, I would have to divide it by 12 over the 100. Okay. So what's that going to be? That's going to be, Alice, can you give me the values with the decimal places, if that's all right? Okay, I've got 1.004, thanks. And then that's going to be multiplied by your current term. And then because this person's making payments of $3,517.28, that will bring that loan balance down. So you would have to subtract it by that amount. Oh, good. All right. Moving on. All right. I'm gonna do this question here. Actually, yep. I'm gonna do this question here. The reason being, we've got a scenario where we have to use the nth term. So they're asking us to find the monthly interest rate, right? And by the looks of it, this is hang on. They want us to find the annual interest rate. By the looks of it, this is saying that it is compounding monthly. So you would say 1 plus, you do not know what the rate is, divided by 4 over 100, right? Is supposedly how much? 1.004, right? You will find that R is actually equal to a 4.8%. True? So hopefully you guys are managing that. You can do menu algebra solve for this. Now they've asked us to find the value of the savings account after 12 months. Yes, we can use recursion and do this 12 times, but we also have another set of equations where we can find the nth rule or the nth value, right? The rule for the nth value. And that is generally given by S0 multiplied by R. Oh, hang on. I made a mistake here. That was 12. My bad. How much is that going to be, team? Oh, that's still 4.8%, right? I think I used my knowledge from that previous question there. Is that right? Did we get 4.8%, team? Yes, no, maybe.
Yeah.
Yeah, brilliant. Okay, so R to the power of n, right? So S0 here is nice and easy. It's a 5,000. And then I've got my, capital R, which is that 1.004. If I want 12 months, I've got to raise it by the power of 12. So can I have someone put the value in the chat for me for that as well? Brilliant. So we got 5,245 and 35. Okay, nice and easy. Brilliant. We might have a look at this question here as well. So with this one, we could just use this recursion rule to find out what the starting value is, right? So essentially it's A that's going to go through that. So you would say, 1,584 is going to be equal to 1.056 multiplied by your initial value. Oops, actually. What am I trying to do? Multiplied by A. And then I can say A is equal to 1584 divided by 1.056. Good. Till what year questions we can use?
I'll answer.
Yeah, cool. Yep, so then this will end up giving you 1,500. Then they're asking us to find the balance of this savings account 4 years after it was opened. That's pretty easy, guys. We're asked to find P4 then. And that's going to be equal to 1.056 to the power of 4 because it is compounding yearly. All right. I'm going to multiply by the 1,500. 1865.29. Cool. Alice Amber's asked about NHT as well. What NHT means. Cool. All right, let's have a look at this question. Now, this should be a piece of cake because I've shown you guys the graphs and I've taught you how to identify it. So I'd like to see the letter posted in the chat, please. If you can let me know what you think it is going to be. Nice and easy. All right, brilliant. You guys are acing. Oh, we've got a B. Remember, if it is unit cost, okay, maybe if I go back to my graphs, I should probably also say that this is flat rate plus unit cost, okay? Unit cost is actually a scenario we've got the same amount going down. Okay, so it's an easy A, isn't it? Right, good. Moving on. Let's have a look at this one. Okay, I'd like to see the answer to this. In fact, I'll probably go and put this up on Mentimeter for you. Question 20. Let's see what everyone thinks of this one. What am I going to do? Why is this not going back? Hold up. Question number 20. Where are we? Do you have that in there, Alice? Do you know? Because you've got a red dot against it.
Yeah, sure.
That's fine. We might just use the chat. All right, whilst we all right, let's use the chat, guys. Let me know what's happening. So first thing to note is you need to check whether there is it appears to be linear or if it appears to be curved. Right now, to me, it looks quite linear, right? We've got a scenario where up until the second month, it's declining at a certain linear rate, right? They're both linear, but then what's happening is this one's even steeper, right? So that means this one, the gradient's even higher. So what we're seeing is a scenario where the weight is increasing. So it's definitely not reducing balance. So I can eliminate that. It could be unit cost, but what happens is an increase in units, right? Not decrease, right? Okay. So it's not C either. So flat rate depreciation, so that would work for both of them. However, what we need to see is an increase in the depreciation rate after 2 months. Okay, cool. Moving on. I am going to have a look at, we might do an extended response question. So let's pick one good amount. So these seem too straightforward. Let's go to okay. Nope. Yeah, let's do question number 16. Okay. All right, let's use the chat. Sana, you've asked me whether flat rate is linear. Yes, it is. And those two lines did appear to be linear. Okay. Oh, so with this one, we can say after 8 years, right? So 38,000, take away 16,000. That will give us how much of this vehicle was consumed or how much of it was, depreciated. And that needs to be divided by 8. Let's see what I've got in terms of values. I've got 22,000 divided by 8 is 2,750. So obviously that's what they've asked us to show. And then they're saying the caravan traveled 5,000 kilometers in each of its 8 years since it was purchased. Okay, and if it's depreciated by unit cost, how much is it depreciating by each year? That's nice and easy. 2,750 is how much it's going down by each year, and 5,000 is the distance they're traveling. Okay, that should be pretty simple for you as well. Okay. Moving on. Cool. Let's look at this one here. Now, when it comes to comparing loans, right? So this is something that you see with actually, I probably shouldn't go down that part. So in terms of interest rates, what we want to do is, what banks generally tend to do is they give you the nominal interest rate. Okay, nominal interest rate. So to calculate which loan is which loan or investment is better, we've always got to consider what the actual effective interest rate for that loan is going to be. Okay, now there's an actual way to do this using the calculator. For the TI Inspire, you need to go to menu, financial maths, and let me check, what was that? Financial. Menu, finance, and interest conversions. And then you want to go to effective interest rate. And then you would say, if it's 12.6, so I think it comes up with F like this, and compound in weekly. So we've got 52 weeks in a year. So you put 12.6 comma 52 like that. Alice, you want to go through the class bed stuff? Is it? I think it's also in interest conversion, isn't it?
Mm-hmm. Yeah.
Yeah. But in your case, I think you have to put it the other way, isn't it? Like you have to put 52 first.
You can just do it on, if you go on like Finance Solver, you can just go if you go
Finance Solver,
and then you go Calc 1 interest conversion,
yeah,
and you can just put in
you can plug in the values. Yeah, I remember that as well. Cool. All right, team, what do we have? What's the recommended? So the first one, what's the effective interest rate? So let's go for I. Effective interest rate is at 13.4. Okay, actually, when fully paid, the loan will cost Daniel the least amount. Least amount is what we're after. What about this? What is the interest rate for this? So maybe put 2 and write the value, so then I know which one you're referring to. So I'm going to say, if your name starts with A, you do 2. If your name starts with a B, you do 3. If your name starts with a C, you can do 4. If your name starts with a D, you can do 5. Let's see if we've got everyone. So I've got 13.6 for the second one. Is that right?
Yeah, 13.6.
Actually, Alice, might be easy if you plug that in your CAS. Whilst we wait.
13.75.
Okay, so 13.5 for 4. Very good. Thanks, Cooper. And what was that? 13.75. Yep. And Daniel. All right, folks are asking me how to do it on the CAS. Alice, I'm going to go over how to do it on my TI, and then I'll pass it over to you to do it on the ClassPad, okay? All right, gang, let's do this. So we go on to finance, and I want to do interest conversions, and I want to calculate effective interest rate, okay? So it comes up with EFF like that. If you want to convert 12.6, oops. If you want to convert 12.6 and it is compounding weekly, you divide it by 52 or put 52 like that, press enter, you will get the interest rate like that. Okay, so hopefully that was good for you, Alexis. And Vanchika wants me to do it on the ClassPad. Alice, I'm going to hand it over to you.
So if you go on financial solver and then Calc 1, you can do interest conversion. N is the number of compounding periods per year. So let's say that's 4. APR is the nominal interest rate. So that's like the one that they've given you in this question. So 13.2, let's say, and then you just click on this button and it will calculate the effective interest rate. Cool.
Cool. All right, let's move on. Think that should bring us to nominal and effective. Oh, here we go. We've got the calculator functions here. If we need to do it. Hang on. All right, we've got 4 minutes to go, and I'm going to go over the financial solver content really quickly. So with the financial solver, these are the different sort of terms that you need to plug in. So we've got NIPV payment, FV, PPY, and CPY. What you need to remember, team, is if money is going out of your pocket, right? So if you're going to go and put money into the bank, right? And that's your payment, that will be a negative because money is going out of your pocket. So the positive or the negative is dependent on where the movement of money is. If it's going from you into the organization or the bank or wherever it is, then it is a negative. If it's coming from the organization to you, then it will be a positive, right? So for example, if you were to borrow money from a bank, money is coming to your pocket. So at present, you would have a positive present value coming to you. Okay, so that's the easiest way to try and remember it. I'm going to try and draw these 4 scenarios before we jump into the break. The way I see it is in terms of a reducing balance loan, right? I'm going to try and help you guys visualize. I'm going to say this bank gives you a lump sum, okay? And then each time what they will do is they'll charge a certain amount of interest and you'll say, here you go. There's a little bit of interest plus money from me, okay, to pay down that loan amount. Next time, the same thing happens. It'll charge you some interest, but you're like, all right, here's a little bit of interest plus money from me to pay down that loan. Now, this will continue like this, right, until you have got 0 in your loan, okay? So in terms of N, that is going to be N times T. I'm going to have to fly through this. Sorry. N times T. Your interest amount is going to be your rate per annum. Nice and easy. Your present value, because the bank is giving you that lump sum or that money is coming into your pocket, that will be a positive value. All right, team. Okay. You're getting that amount to your account. So it's going to be a positive value. These payments here, right? You're paying the bank. Look at the direction of the arrows, right? Therefore, it will be a negative. Your future value can be either a negative because you still have money that you have to pay, or a 0, right? Okay, meaning you have paid out your loan. PPY and CPY will be N and N. Okay, interest-only loans. How's this different to reducing balance loans? The bank gives you a lump sum of money. Okay, I've really simplified this. UBS folks, I've tried to simplify this as much as possible. What's happening is, let's say, the bank goes, okay, because we've offered you some money, we're going to charge you interest each payment period. You're like, all right, if you charge me $1, I'm going to repay $1. Okay, so the balance again is going to be these $3 that you owe. All right, guys. Okay, you get charged $1. You're like, all right, no problem. Here's my $1 that I owe for interest. Now, ultimately, what's going to happen is this can continue until forever, until you are going to have to pay back that original $3 that you have borrowed. Okay. Again, I is our present value. Because you received a lump sum of money, that is going to be a positive. Your payment, because you are going to continue to pay. These green lines, money is going out of your pocket. All right. Okay. Because of that, that is going to be a negative. Now, one thing to note here, team, is ultimately your future value will have to be a negative because of this lump sum payment that you have to make. Now, you also need to remember that these two values here will be equal to each other, because whatever the amount that you have borrowed, you will ultimately have to pay back the lump sum payment. Payments per year and compounds per year will be N. One thing to remember about both perpetuities and interest-only loans, because we're only considering the compound for one of the periods, N will always be equal to 1. Okay, so don't forget that. N for interest-only and perpetuity is always going to be equal to 1. What happens in a perpetuity? It's quite the opposite of what happens in an interest-only loan. Okay, the person goes and, I'm going to go with my dollar stories, right? A person goes and gives $3 to the bank. Okay, and the bank's like, all right, here's the $1 of interest, and you're like, that's fine, thanks for that, I'll take that $1 back. Okay, so this person will continue to earn interest and keep receiving the total amount of interest back. Okay, this is a really simplified version of perpetuities that we learn in further. Now, this can happen forever until the bank goes, all right, your term has matured, so therefore here's all the $3 that you gave at the start that we've been paying you interest on. That is going to be your pink. Okay, again, just like with that previous question, your present value, you need to remember, because you're giving money into the bank, that is going to be a negative. Your future value, because the money is coming back from you, that's going to be a positive. However, you must remember that these two values are going to be equal to each other. Interest amount is rate, right? Payments per year and compounds per year will remain to be N. Moving on to annuities, okay? Annuities are similar to what you see in a reducing balance loan. Cooper's asked me, why is N equal to 1? That's because for both interest-only loans and perpetuities, Cooper, we only consider one payment period because the interest amounts don't change. Okay? It remains a constant for each and every period. So we only need to consider one of them. Cool. All right. With an annuity, what happens is this person goes and gives the bank, $3. So the bank's like, all right, here's $1 of interest. Guys, this is, like I said earlier, very simplified version of it. But the bank's going to go interest plus a little bit of how much you have given us. Okay. Interest plus a part of your, deposit that you've given us. Again, next period comes along, interest plus a little bit comes back to you. Next period comes along, interest plus a little bit comes back to you. Okay. Now this can keep happening until it becomes a 0, because until your annuity runs out. Okay. So with these, N is going to be N times T, which is the number of compounding periods times the number of years. I is going to be rate. Present value, because you have gone and put money into the account at the start, that will be a negative, money going out of your pocket into the bank. Okay, this is my bank, my bank, my bank. Okay, payment, you're going to continue to receive money, therefore that will remain a positive. Future value. Ultimately, either you will have a lump sum that you're meant to receive, or you will have consumed your annuity in total. Payments per year and compounds per year will be N and N. They don't tend to change that too much in the exams. Annuities with additions to your principal. Now, these are the super savers, right, folks? What happens is, this guy goes and deposits a certain amount. The bank's like, all right, here's your interest. And the person's like, all right, cool, keep the interest and deposit this dollar as well. Cool, right? The bank goes, all right, here's more interest. And then you're like, all right, keep the interest plus here's more dosh. Okay, so this can continue happening until eventually you're like, all right, give me all of my annuity back to me. Okay, so N is going to be N times T, I is going to be R. Present value, you have gone and put the money into the account, therefore it will be negative. Payments looks like you will be continuing to deposit money into the account, so it will be negative. Future value will be a huge plus because ultimately you're meant to receive all of the money plus the interest plus the payments, and payments per year and compounds per year will be N and N. Okay, cool. With that, Alice, I'm going to hand it over to you for the break.
Yeah. Sounds.
I'll stop sharing.
So just a short video before our break.
Hi everyone, my name is Ben Crofts and I'm an investment banking analyst here at UBS Melbourne. I think the way that I describe what I do is I'm effectively a real estate agent, only instead of selling property, I'm helping to facilitate the sale and purchase of businesses. I think, career highlight so far has been the opportunity to work with so many like-minded and intelligent people, as well as being able to support UBS's recruitment program, which I found to be really rewarding. Prior to studying at UBS, I completed my Bachelor of Commerce degree at the University of Melbourne. Whilst there, I majored in finance and particularly enjoyed investments, corporate finance, and derivatives. Obviously, prior to that, I completed high school here in Victoria and completed my VCE. Whilst in high school, I particularly enjoyed mathematics. I actually did specialist methods and further, which was quite unusual at the time. And also obviously did English, also did physics and accounting. But I think if I had to choose a subject from memory that I enjoyed the most, it was probably specialist maths. So I think I might reframe this question slightly to be advice for my former self rather than my future self. So if I was able to advise my former self on anything, it would be to get involved as much as possible at university. Uni is really one of those things where you get out what you put in. So I'd recommend that my former self get involved in as many clubs, groups, societies, and events as possible. It'll really stand you in good stead. So if I were advising myself a few weeks out from my Year 12 exams, I think I'd just tell myself to relax. You've done the hard work up until this point. You've worked very, very hard with your teachers and your classmates to ensure that you're prepared for this upcoming sort of exam period. And now is just an opportunity to demonstrate what you've learned. The entire process is over in the blink of an eye, and before you know it, it's holidays, and then you're in uni, and then before you know it, you'll be in the workforce. So try to make the most of the time, enjoy of it what you can, and look at it as an opportunity more than anything.
Okay, we are having
Hi everyone, my name is
a break until 2:35, and then we'll come back and finish the rest of finance.
So I have to admit this, and I know it's not cool to admit this, but like when people talk about deep breathing and breathing exercises and watching your breath come in and out, like I literally go, oh my God, I don't know if I can do this. Like, I don't know. That is completely on me. Like, that's totally on me. I just don't get something. But there is an element of our breath that I've learned something about that, like, seriously, it is super cool. So here it is. When we're feeling really stressed or really anxious, like when something's really important to us and we want to perform well, what happens to our breath is that we start breathing really shallow breaths and lots of them instead of a few breaths and really deep breaths. And the more stressed we feel, the more shallow the breathing is, so basically stops about here, the more frequent the breaths are, and they start to be these like really short, shallow breaths, almost like we're panting, which can lead to completely hyperventilating, like in full-blown anxiety. So here's the thing that I really love. Our breath is one of those things that we do automatically, like we don't have to think about breathing, we will automatically breathe, but it's also something that we can control. So it's something that we have a say over. Like we don't have a say over how fast our heart's rating. We can do things that can slow that down, but we can't go in the moment. We can't go, okay, heart, I want you to beat this many beats per minute, right? With our breath, it's totally different. We can go, you can take 5 deep breaths and you can change it from going to really long, deep breaths. And there's something extraordinary that just by virtue of the fact that we have control over this automatic system, it actually changes our capacity to speak to our brain when we're kind of freaking out. Like, and most times we don't feel like we've got any way to have our body communicate to our brain, but here we actually do. Here's what you can do. If you find yourself in a position where you notice your body's just doing that stress response and you're breathing shallow, you can actually decide to take a few deep breaths. And what that does is it communicates to your mind that you're okay, because it knows that if you're taking short, shallow breaths, something's wrong, right? That's an instant communication to your brain that something's wrong. And then it wants to step in and deliver you those stress hormones like adrenaline and cortisol, which amps up the stress response, which makes you breathe even more shallow. If you can send a signal to your brain simply by taking a few deep breaths, it'll go, cool, Leah's relaxed, she's chilled out, like there's nothing wrong, just gonna cruise now. Like that's how it works. I hope this helps. I really hope it helps. Let me know.
Okay, we are going to do some examples of using Finance Solver now, and then go through amortization tables, and then that will take us to the end of the day. So let's do this first multi-choice from last year, which only 40% of the state got right. So my advice with Finance Solver questions is to highlight or underline the key parts of the question, because really you're just looking for what you're going to be inputting into Finance Solver. So immediately we can see our interest rate compounding monthly. After 10 years, made a one-off payment, and for the next 10 years, the account earned interest of 2.8%, and the balance today is that. What did he originally invest? So we need to work backwards in this one to find what, how much was in the account after the next 10 years, right? So if we make n be 10 times 12, our interest rate would be 2.8. PV is what we're trying to find out. The balance is going to be negative monthly payments. He's not making any payments, so nothing. And if we put that into Finance Solver, We should get
I will plug this in for you. So what have we got? We're looking for present value. What was the payment amount again? Sorry, Alice.
no payments.
Oh, no payments. 86. Here we go. Someone's Ryan sent us the answer already.
Oh, very good. So 519,320.3. And then if we subtract that $10,000 from that, right? Minus 10,000, we get 509,320.3. And now if we go again, now, oh, sorry, my highlights have gone funny. Now we input this into our future value instead, because that's what he has at the end of the first 10 years, right? So that would be negative 509,320.3, still 12. The interest rate in this first 10 years is 3.2. 12 times 10, there's no payments, and we're finding our final value again. Why is FV negative? So if you think about, you always make, if you're in possession of that money, you have that money, then it's positive because you have it. So that's like a positive thing, you have the money. But if the bank is in possession of that money, then it's negative because you don't have that money. So bad thing, like you're not holding that money, right? So it's negative. So in this case, the money is in his account, which is the bank having the money. So that's why it's negative. And awesome. Thank you, Ryan. He's saying that our PV would be 337. So that gives us B. So that's quite a lot of work for a multiple choice question, right? 2 steps for only 1 mark. You know, if I was doing my exam and I saw this question, I'd probably leave it to the end because there's bound to be some multi-choice questions that are quicker to do. So if you're struggling for time, this is one of the ones that you would leave to the end. Let's go through this short answer one. So you can see that only 19% of the state got the full marks for this question. So bit of a trickier one. So highlight key information, step 1. Interest rate was 4.1 monthly after 4 years and then after 7 years. The final repayment will be lower. In the first 7 years, he made 84 repayments. From this point on, how many more monthly repayments will he make to fully repay the loan? So 2 steps again to this. First step will be to, so we have to work out, how many payments. So we know that the first 7 years, after 7 years, he has that much, 280,000 left to pay, right? And we have the interest rate monthly. But we don't know what the repayments are. So we need to, first step is to work out what the repayments are. So we go NI, Also, in the short answer question, writing out what you put into finance solver counts as working. So you need to write this out, and this is how you get your marks. So N would be, we're told 84. Interest is 4.1. PV, payment is what we are trying to find. Final value would be at the 7 years, so -2.8. Actually, it's positive because you are in possession of that loan. So 280,875.15, 12. Calculator. If he's making 84 payments was in 7 years, but we're going to look to find, we're only told what it was at the start of 4 years to 7 years. So our PV is going to be this starting value at 4 years, right? So 329,587.25. So actually our N will be 12 times 3 instead, and we can work out our payment value, which you can see that his payment is $17,090.79, right? So now we can use that in our second step, which we are going to find out how many more repayments to pay off his loan, right? Interest, present value, payment, final value. So we don't know N. We know that our interest is 4.1. Present value is 280,875.15. Payment is what we just calculated. So that is -17,090.79. Future value is going to be 0, and PYCY is 12. So if we put all of them in here, and we click on N, we can see that N is 16.9. So then we have 16.9 payments, but we know that our final payment will be lower. So that's why we have that 0.9. So we have to round up, and we would say that our answer is therefore 17 more repayments are needed to repay the loan. Cool. Let's have a look at the next question. So, question 7. Ken has borrowed $70,000. He's charged interest at 6.9, compounding monthly. For the first year, he makes repayments of 800. Find the amount that he owes after 12 repayments. So we just go back into, in this case, see that it's only worth 1 mark. So it's only asking for the answer. So you don't have to show your working, but if you want to, you can write it. So we know that N will be 12. Interest rate was 6.9. PV, present value, positive 70,000. Ken is in possession of the 70,000. Payment is negative 800. Ken is giving $800 to the bank to pay off his loan. And final value is what we're calculating. So we click on that. The final value after his 12 repayments will be $65,076.22. What is the total interest that Ken will have paid? So when we're calculating total interest, total interest, okay, go back. Total interest is equal to our length of the loan times payments minus the starting or the principal amount, right? So this is like saying the interest that you're paying is equal to the total amount paid minus the principal or the starting value. So in this case, we can say that our length of the loan, so in this case 12 times our payments, which was 800, minus our principal, but in this case, actually, we are just looking at how much the loan has gone down, right? So in this case, it's gone down from 7,000 to 70,000 to 65,000. So we're going to then subtract that. This is just like a general, which you have to adapt to the situation. 65,076.22. And then if we solve this, we get our total interest paid, which is 4,676.22. So the interest paid is the difference in the amount that you have paid and the amount the loan has decreased in value, right? So usually you would do, when you do the principal, that's if you're doing the entire loan. So that would mean that like you've gone down, like the loan has decreased by the entire value of the principal, right? Continuing on, after 3 years, he makes a lump sum. This sum ensures that he is fully repaid in 3 years. Repayment amount remains at 800 and interest stays the same. What is the value of the lump sum? So this is 2 marks. Step 1 will be to work out how much is still left in the loan after 3 years, so that then we can use that to then calculate our lump sum. So step 1, calculate how much is left after the 3 years. So this would be 3 times 12. Interest is 6.9. 70,000 negative 800. Final value is what we would be calculating. 5 in 3 times 12, 6.9. We get 54,151. Then our next step would be to calculate the lump. So in order to calculate the lump sum, we're going to work backwards and calculate what that present value is when there is, like, we're going to calculate the difference between the present value and, or the final value after 3 years and the present value of the, like, further 3 years, right? So if we have another 3 years, our interest is still the same. If we calculate this, our payments are still 800. Our final value will be 0, right? We want to calculate what that final value, that starting value to get to 0 will be. So I'll just write that's 0.60. To get to 0, we have to be at 25,947. .58, right? So then our lump sum is going to be the difference between those two amounts. So it would be 54,151.60 minus 25,947.58. Which is equal to $28,204.02 would be the value of his lump sum. Okay, let's do another long answer. So again, highlighting or underlining the key information. So donation, $5,000, compounding monthly, deposits a further $100 into the account. After 5 years, they would like to have a total of $14,000. What annual interest rate do we need to achieve this goal? So we can just use Finance Solver again for this. So we can go N. So N will be after 5 years, so 5 times 12. Interest rate is what we are trying to calculate. PV was $5,000, right? And they deposited it, so it's in the bank, so that will be negative 5,000. Payments are, they deposit $100 each month, so that's 100. The final value is that they want 14,000, so we can put in. And this is yearly, monthly. So then we can calculate our interest rate from that. So we can go 5 times 12. Interest rate we don't know. Negative 5,000, negative 100. Sorry, this will be positive 14,000 because eventually they're going to get all that money back, right? And we get our interest rate is 6.5%. Oh, they want 2 decimal places, so it was actually 6.5 4 if we go to 2. Percent per annum. So important thing to note is that the interest rate in Finance Solver is always per year, or is always the annual interest rate. Okay, so you don't need to, you always put it the annual interest rate in, not monthly interest rate or something like that. So actually the interest rate is lower than that. It's actually 6.2. After 36 deposits, the community stopped making the additional payments. How much money will it have after 5 years? So 2 steps to this problem is to find out how much money is in the account while they're still making the payments, and then how much money, how much does the investment grow once they stop making payments. So if we do step 1 first, N would be 36 in this case, 6.2, negative 5,000, negative 100, 12, and we're calculating FV. $9,964.63. Oh, thanks, Alexis. 9,964.63. Then step 2 will be to use this value that we just calculated and do the, so 36 payments is only 3 years. So now we need to do the other 2 years to get to 5 years. So that would be 2 times 12, still 6.2. Now this goes in there, so negative 9,964.63. Our payment's now 0, and we're calculating our final value. And final value 11,200. Perfect, thanks, Alexis. Too quick. So we get 11,276.52. So then we would make sure to take this out of the context of Finance Solver and use the dollar sign. 11,276.52 is the final answer. Let's do one more Finance Solver question, and then we'll go on to amortization tables. So let's do question 9. Phil borrowed 35,000, 4.9% fortnightly, 3 years of payments. The balance is left that. What is the fortnightly repayment? So again, this is only 1 mark, so we can just go into Finance over there. So after 3 years of fortnightly, so if it's fortnightly, that is times 26. 26 fortnights in interest will be 4.9. PV positive 350,000. Payments, we're calculating final value will be 262,332.33, and make sure to change these to 6, and our payments are 7,954.54. what is the total interest Phil will have paid? So if we work out the total amount that Phil's paid, that will be 7,954.54 times the number of payments, which is 3 times 26. And that is equal to 7,954. $620,000. But the loan has gone down from 350,000 to 262. So 350 minus 262.3333 equals 87,667.67. And then the interest will be the difference between the balance and the total amount that he's paid. So it will be $532. Cool. Adrian, do you want to go over the table?
Cool, will do. Thanks for that, Alice. All right, everybody. So we are almost at the end of the content for financial maths. And I'm just going to run you through amortization tables really quickly. So you will notice that, you know, this, if you've already started doing your practice exams, you'll notice quite a bit of this type of question in those exams. Now, what we've got here is I've given you the set of equations that you can use to find each of these, I suppose, columns or values that will go into these columns. Now, one thing to remember always is that the interest paid here, we need to consider the interest paid per period, okay? So the rate is always divided by that n, okay, which is how often it is compounding by. So for example, if I needed to find the interest period for this one, or interest paid for this one, the first row there, I need to have this balance, okay? So we consider the previous balance when we're calculating the interest period for the following period, okay? Principal reduction is going to be your payment amount. So I'm going to say this payment amount, take away your interest paid, right? Take away your interest paid. And then ultimately your new balance, we might go and use a different color. A new balance in one of the rows will be your previous balance, which is this guy, take away your principal reduction. Okay, so that's the sort of relationship that we have between each of these columns. So let's jump right into one of these questions, guys. In this question here, it's asking us to calculate the, let's have a look. Interest rate is calculated monthly, and Samuel's making a payment of $1,600. That's easy. Interest charge 3.6% per annum. So that's per annum they've given us. So then because this is monthly, isn't it? Yep, monthly, that would be 3.6 divided by 12. We've got to remember that. Calculate the balance of the loan after payment 4 has been made. The balance. Let's see, what are we missing here? Are they asking for other values? Okay, so looks like we would have to go and fill in the rest of the values first. So Alice, are you okay to help me with the calculated stuff? Yep, you're on mute at the moment. So the principal reduction here for this is going to be the payment amount, which is 1,600, take away the $956.15.
$643.85.
85, thank you very much. And then we want to calculate the interest amount. So that will be my previous balance. So this is going to be, right? Actually, maybe I'll use a different color for that. This here is going to be my previous balance, which is $318,074.23, multiplied by, I got to remember 3.6 over the 12 because I want to find the interest amount per period, right? Over 100. So this question is from exam, the 2020 exam.
954.22.
Thank you very much. And now what do they want? The balance of the loan after payment 4 is made. So interesting how they're expecting us to do all of this work just for the 1 mark. Okay. Anyways, let's do this. So we want to find the principal reduction here. So how much is that? That's going to be 995.
It'll be 600 and
1600 take away 954.22. How much is that? What do you say?
145.
645. Yep. Thank you. And 78. So I can say finally to find the balance of the loan after payment 4 is going to be $318,074.23. Take away $645.78. Team giving me, anyone done this?
317,428.
Point anything?
45.
Thank you very much to the nearest cent. So whenever they say to nearest cent, team, that's 2 decimal places. All right. So SN, and they want to find the month-to-month balance. Okay, nice and easy. S0, which was my initial amount, is how much I have borrowed, and I have borrowed $320,000. Okay. My next term will be my current term multiplied by 1 plus 3.6 over 12 over 100. And that gives me how much? Is it a 1.003?
Yep.
Yep. And minus, I've got 1,600 that I'm going to be keeping on paying per payment. Okay. So hopefully you guys are comfortable with that process. All right, let me see how many more questions have I got. Okay. Got the summary is brilliant. So let's do this question here. They want us to find out the payment number. Okay, good. All right. Now, the obvious answer, or you know, you might just assume that 100 is going to be the payment number, because essentially, you know, they're saying, well, they've been paying me 100 each, right? But we can't always assume. Okay, it could be a case where in one of these payments, they've made an extra payment. So the first thing that we want to try and find out is how much this interest amount here is going to be. Now that's pretty straightforward. Actually, it is not straightforward because they have not given us the interest rate. The first thing that we need to do is we have to go and calculate the interest rate, right? So that's going to be, and the interest rate per period, right? So I said, you know, the interest amount was actually, you know, the rate over 100 multiplied by the previous balance, right? However, to calculate the actual rate, what we might need to do is we might go interest, okay? I might go interest over balance or previous balance multiplied by 100%, right? So how much is that? That's 27.91 over $6,977.50 multiplied by 100%. How much does that give us, Alice? Okay, I've got a, is that a 0.4% then? Ryan's given me the answer. Yep, brilliant. Cool. All right. So I've got 4%. So I want to go and find out how much the interest amount is going to be. So technically, I've got to go and say, well, 0.4% multiplied by $72.33 and 83. Can someone give me what that value is? Alice, are you able to help me out with this?
0.94.
0.94?
28.9.
28. 28.94. And then ultimately I need to calculate what my principal reduction is going to be. So that's going to be, that value, take away that value, or principal addition rather. Yeah, how much is that?
266.17.
266.17. Thank you. And to find the payment amount, guys, all I need to find is the difference between these two, right? So what's that? 230 something, 237. Cool. All right. I might go into this question here, please. And we might do this on this question.
Very last.
Alice, I think you're presenting.
Cool. Should work now.
Is it presenting?
No.
No. Cool. Oops. Wrong one. Is that this one? I have no idea why it's not letting me here. Let's go present. This one. Let's do this question, team. I haven't got any answers yet. I've got one person that has answered it. We've got 5. Good. Might wait until about 20 of you guys answer it. Got 9. Come on, team. Let's get it. All right, 4 more and I'll do this question. 3 more. Oh, all right. So let's have a look at what's happening. Majority of you guys have recognized that it is monthly. So let's see if that is the case. So first of all, we need to calculate how much the interest rate is based on this information here. So I'm going to say 900 over 300,000, righto, multiplied by 100%. So how much does that give us, guys?
0.3.
0.3. Then we've got 3.6 divided by n is equal to a 0.3. So n is going to be equal to how much? Monthly. Okay. Brilliant. So what time is it? We've got 10 minutes to go. Alice has done some really good recursion and finance summary notes for you here. Now, in terms of first of all, actually, I would really like you guys to all go and submit the evaluation. I will, or Alice, have you got the?
Yeah, I'll get it.
Yep. This is essentially what we use to improve our content that we deliver each year, guys. So It'll literally take you, just under a couple of minutes. So if you can please complete this survey, that will be really useful for us. You got it? Cool. All right, I'm going to give it a few minutes because I can see how many of you guys are filling in the survey. And I'll move through some of the next few slides around tips and things like that in a bit. Cool. If you could all please take a moment to fill that up, that would be so good. All right, thanks everyone. So some of you guys have asked me, what's the plan for the next couple of modules? Because as you know, we've only done the data and financial maths components for today. But we've actually got the weekly topic test content that we deliver on a weekly basis. So over the next couple of weeks, starting from the 30th of September throughout until the 21st of October, we're hoping to cover the following modules, and we're going to take a similar approach. So that's going to be essentially, a little bit of content, but trying to go over as many exam questions as possible. Like I said at the start, guys, we obviously had very limited time to be able to go through a year's worth of, or two major modules worth of content. So, I really hope the way we've broken it down for you, you'd have the opportunity to go and look at this work solutions and reports on Vika. Okay, so the Vika website actually has them. So for any questions that we haven't completed today, that's what I would encourage you to do. Go on Vika, find out the question, look at the report, pay attention to especially the questions where students haven't performed that well. And look at what the key learnings are from them so you can avoid that or avoid making those mistakes in the actual exam. We also have, sessions run by Leah, the wonderful Leah. I think you guys saw a couple of clips from her today. She runs some excellent sessions around how to manage stress and how to hack your exams, avoiding things like panicking, anxiety. So if you're interested in using any of those services, you've got the link there to book in a time. You can get in touch with your school and see if that's something that you want to have for the entire school as well. Now, questions, but before we do questions, we might go and do this final confidence survey. So I'm going to go back here. Oops. Here we go. So I think we asked this question at the start, and now where are we at? Is this the same questionnaire that I'm asking though? I got to make sure I'm right. Yep, that's the right one. Sorry about that. It's taking its own cool time. All right, here we go. So if I can get you guys to type up or select a score for how confident you are feeling at the moment, that would be good. So I've got about 41 people that have responded, and we've got 100 here. So it will be really good to know where everyone's feeling at the moment. And is the scale up until 5, Alice? Is that how you created it?
Yeah.
Okay, cool. Cool, so we've got 54 and counting. I'll give everyone a couple of minutes to add their scores.
while they're doing the scores, we have a few questions about what to include in our bound, what to include in your bound book.
Mm-hmm.
So my recommendation would be to make sure that you have all of the key equations, anything that you constantly are forgetting, including things like the normal distribution equations, interpretive statements, are really important to put in. Also, I think super important is any questions that you constantly get wrong, paste them in and put in your worked solutions for those questions, so that if a similar question comes up on the exam, you can refer to how you've done it previously.
Cool.
Just making sure your notes are really clear as well is a big help, because anything else to add there, Adrian?
No, I think you've captured everything in terms of the notes. We had a couple of questions earlier whether we should use the textbook or write your own notes. If you're probably trying to write your own notes now, I would say it's a little too late in the year. I always do encourage students to have their own bound reference rather than taking a textbook. As you know, the textbook tends to have a whole heap of questions that don't necessarily have answers to, and it's a little bulky, and you don't want to be flipping through the pages when it's that bulky. So my advice is to try and get your own notes, take your own notes in, and hopefully through things like the worksheet that we provided today, as well as the VCA exams, you are able to recognize key concepts where you could go wrong. Okay. One of the good things that I encourage my students to do is I get them to sit, company exams and VCA exams, and I ask them to prepare an Excel spreadsheet. So you would say, okay, for data, out of 24, I've got 23, or out of 24, I've got 22. And then you'd say, oh, I made a careless mistake in rounding, right? So what you do is you prepare this whole spreadsheet of errors that you've made, and you are the assessor. You're like your own assessor, and you've got this database of common, if I was to do it, common Adrian errors. Okay. And what you want to do is you want to do this up until the exam, right? So potentially, over the next couple of weeks, you'd be doing about 4 to 5 practice exams per week on a minimum. And you will have this massive repository of all the errors or all the things that you need to watch out for, because you've written those reports yourself, right? And in doing so, whenever you come across a similar question in the actual exam, alarm bells are going to go off in your head going, all right, I've got to watch out for this, because this is something that I always make careless mistakes in. Okay. And even concepts, right? The best way to recognize which concepts you lack confidence in is not to just blandly go and do practice exams. You want to have a record of what you have been doing. Write it down, identify what types of questions, and clearly articulate it in that Excel spreadsheet so that you can follow up yourself. Okay, so hopefully that was useful. What else do we have in terms of questions, Alice? Should we go to Ask Me Anything? Okay, access this recording. So that is going to be on your Eventee page. So whichever the system that you would have used to log into today's meeting, that's where you will find the access to the recording. Do we get any resource from the lecture, or should we take notes? Hopefully you've taken notes throughout the session, but whatever we've got here will also be uploaded.
The only other question in Mentee, this one, tips and tricks.
Yep.
I think for further, especially, is just, it's about doing as many questions as you possibly can between now and the exam, as I'm sure you'll become aware that they repeat the same questions with just different numbers and different names. So once you understand the style of question, then you're pretty set. So the more you can do, the better off you'll be. I
can definitely second that. With further maths, the style of questions tend to be repetitive over the years. Like I said earlier, with today's session, what we tried to do is we tried to break down the different types of concepts that they assess you on. So if you can go and ensure that you're at 100% confidence in each of those sessions, eventually that's going to accumulate to 100% in an exam. Okay, that should be your goal. And then obviously with further maths, one of the key things to remember and keep an eye out for is the timing. So you know, a lot of the time, exam 1 people tend to finish, you know, on time or in advance, but exam 2 people tend to run out of time. Okay, so that's something that you've got to watch out for, and you want to be, you know, leave the weaker exams potentially towards that last 3 weeks or so, and sit weaker exams under those time conditions and assess it yourself and see how you're performing. Further to what we have already provided, I'm also going to give you guys a breakdown of time allocations per module. So instead of you having to do any calculations in your head, it'll say for finance, between 3 and 3:15, I need to be finishing my finance module. Okay, so that'll be really handy for you to have in your notebook. So all you've got to do is look at the clock. Okay, it's 3:10. I'm still on finance. That's all good because I've got 5 minutes to spare. Someone's asked me, how many practice exams do you recommend? To be completely honest, Cooper, I would recommend you to do as many as you can fit in. Right now, you know, I'm a strong advocate for doing practice exams, right? Because if you're trying to go through content and just, you know, write down notes right now, I do not believe that's the most effective thing that you can be doing. So you focus on practice exams, do as many practice exams, recognize your areas or gaps in your knowledge, and then go back to your notes and try to, you know, fill in those blanks. Okay, so right now you should definitely focus on doing practice exams. Some of my star students in previous years, or you know, Hatch's star students, they've completed close to 50 practice exams. Okay, we've produced like over 40 scores, or I've produced 250s in the past. They've easily done close to 60 practice exams before the actual exam. But don't panic, you don't have to do 60. I did 12 and I still managed to get a perfect score. So, you know, it depends on the student. The more you do, the better you're going to be. Okay. What else have we got? Will we send invite to upcoming module session? Yuval, I think we've already given you the link to it. You actually have to go and book it. So that it's not going to be exactly like today. You may not get the links through Eventee. So just make sure you've got that saved. It's in the chat. Cool. All right. We are at 3:33. I just want to thank everyone for joining us today. I want to thank Alice and obviously Skyline Hatch, all the supporters of Skyline Hatch, as well as UBS for all your tremendous support. And of course, to all of you guys for your wonderful engagement and contribution throughout the session. I want to wish you all the best of luck, and I'll pass it on to Alice for some final comments as well.
Yeah. Also, I just want to thank Adrian for all of his work as well, and UBS who've really supported us, and Skyline Hatch to run this session. Yeah, I think that's all. I hope you guys have learned a lot today and feeling more confident about your exam. Good luck for it all.
Cool. See you guys.
Bye.
I'm just going to wait for everyone's thank you notes and I will end the session. Alrighty, that should be it.